Hi. So before we get started with our project, I'd like to take a moment to go over some Maya interface basics and how to customize it to improve the speed of your workflow. Now, the first thing I would say is learn to use the hotbox. In Maya, if you press space, you'll see that we have menus come up that we can go into and then select things. Now, it's important to learn to use the hotbox because Maya's menus up here change depending on what you're on. So let's say I've been doing some effects and I've changed my menus up here, and now I want a nonlinear bend deformer and it's no longer there. So I go up to modeling maybe and I've got a deform menu. But again, when I switch back to FX, that menu is going to disappear. And this holds true. If I want to get to N hair, I'm going to have to change up here to FX. I'm going to have to remember what's on each one of these sub-menu settings, and it becomes generally a pain. So rather than this, if we take a look at the hotbox, here we have deform, here we have end cloth, end hair, and the dynamics. It always stays at the same place, and it's just a much faster way of working. Now, the other thing you're going to need to know, I'm going to be using some hotkeys during this tutorial. I'll keep it to a minimum because I understand it can be frustrating if somebody's just hitting a bunch of hotkeys and you're not quite sure what's going on. So I will tell you the ones I use, and these are the most important ones to memorize in Maya. So you've got W to move, E to rotate, and R to scale. These are the ones you'll be using all the time. Scale the object, rotate the object, move the object. Now, this is much more efficient than going up here. I don't think I've even used these things. I don't even know which icon stands for which at the moment because I use them so infrequently. So W, E, and R, absolutely essential. The other thing you'll need, if you just memorize a few hotkeys, is F8, F9, F10, and F11. F8 goes into object mode, F9 into vertex, F10 into edge selection, and F12 into face, and then F8 back to object. When you're modeling in Maya, you'll constantly switch between these modes. So hitting the right mouse button and going up here is kind of slow. So if you see me jump into edge mode and then across into vertex mode, you'll know that I'm hitting F9, F10, and F11. So vertex, edge, face, and F8 again to go back to selection mode. So if you hit F8 twice in a row, it will go back to the previously used mode. So for instance, if I'm in vertex mode and I hit F8 and I hit F8 again, I shall go back to vertex mode. Right, so that's basically all the hotkeys I will be using. W, E, R, F8, F9, F10, and F11 for move, rotate, scale, object mode, vertex mode, edge mode, and face mode, respectively. Okay, now one of the other things I want to talk about is the outliner. Now, you won't see it in this viewport. You would go Window, Outliner. You need the outliner open all the time to organize your scene file, to select objects that might be in a bunch of other objects. It's just one of those essential components that should be the first thing you sort of bake into your user interface. So I'm going to grab it and I'm going to dock mine over here. I have it there all the time. You'll see it all the way through the tutorial. This way, if I have multiple objects in scene, I can both click them easily in the outliner and also rename them to keep everything nice and organized. And trust me, if you're working in this field, if you hand somebody a file, texture guy, someone who's going to animate your work, and it's all called polycube 426 sphere 92, that file is going to come straight back to you with an angry note attached to it. So keep your work organized. One of the reasons for having the outliner open at all times. So basically a few hotkeys. When I do the first parts of the tutorial, I will mention the hotkeys and then I'll stop after that. You can always refer back to this part. Now, another thing I would say is a very nice way to maximize your efficiency is to create your own shelf. So these things here are shelves. Now, they contain various different bits and bobs, so the curves and surfaces contain curves and surfaces, polymodeling contains polyprimitives, things like freeze transformations and reset pivot. The thing is, there's so many of these, and you'll probably only find yourself using one or two items off each menu. It's easier to build your own menu. So I'm going to come in, click the little gear icon here and hit New Shelf, and I'm going to call mine Maya tutorial. Now I will make this shelf available at, you cannot have hyphens. I will make this shelf available to anyone who wants to download it. You just bung it in your shelves folder. I'll also make a note of where that is in the download, and then you would go load shelf and you can load mine in. Now I'm going to show you how I build mine and most of the stuff that's on it, so you can build your own. My workflow might not end up being yours. You might use a certain command more often than I do. There's certain things like extrude that I wouldn't put on a shelf simply because the hotkey is Control E, so it's easy to remember. But again, you might prefer to put that on your shelf. So how do we get things from these shelves first off onto our shelf? Well, you can middle mouse drag them, but if you do that, it's going to disappear from the original shelf, and that's probably not what you want. So if you hit Control Shift and middle mouse drag, now in this case I use rather a lot of the EP curve tool and the Bezier curve tool. So I'm going to middle mouse drag the EP curve tool up to the SimplyMaya shelf. I'm going to middle mouse drag the Bezier curve tool up to the SimplyMaya shelf, and there is my EP and Bezier curve. Now, if you can't remember what the icons are, you can go into Shelf Editor. You could click, say, the EP Curve tool and give it a name. So the icon label for you could be EP, and with Bezier could be BC, let's say Bezier Curve. And if I hit Save All Shelves, you'll see I've got EP and BC, so Bezier Curve, EP Curve. Now, if you need that reminder, you can do it. You can organize your shelf in whatever way you want. So I'm going to go through these shelves and plonk on some stuff that I use all the time, and then I'll show you how to get stuff from menus over to the shelves too. So first I'm going to put on my shelf, and you can reorganize your shelf by middle mouse dragging, and that will reorganize, so you don't have to do this in any particular order. So let's look at polymodeling. Now normally when I'm polymodeling I start off with a plane. So I'm going to put a plane on my SimplyMaya shelf. I'm also going to put a cylinder, which I use quite a lot. So this gives me a one-stop shop, if you like. I don't have to keep flicking back between all this malarkey. So I don't use anything from sculpting often enough to justify it. Same goes for rigging, animation, rendering. These are all kind of specialist things that deserve to have their own shelf, in my opinion. So right now that's me for the creation stuff. So creating curves, creating primitives, that's basically what I use. Now, if we come to modeling, there's a few things I use. So if we open up the hotbox and we go to mesh, some of the things I use are combine and separate. Let's see, what else do we use on here? Mirror, of course. So let's do some adding to the menu. So I'm going to hold Control Shift and click, and I'm going to add combine and separate. Mirror, I'm also going to add the mirror options box. So if you click here, you'll add mirror. If you click here, you'll add the mirror options. Now you'll see in my shelf I've got two things. Now I don't particularly want two things for mirror. It's just going to make my shelf messy. So if I right click here and hit edit, I can see the actual command that opens the mirror geometry options. So I'm going to copy that. I'm going to go up here. I'm going to hit edit pop-up on the other one. I'm going to create a new pop-up. I'm going to give it that command, and I'm going to call this mirror options. Okay, now when I close this down, if I right click on this, you'll see I've got a mirror options in the drop down menu. So if you've got one icon you want to represent a lot of commands, you can just keep adding pop-up commands. That way your shelf's not all messy. Now I don't need the mirror options because I've got them both in one button, and I can continue to add things to my shelf that I'm going to find useful. Now when it comes to modeling, mirror is useful because we'll normally model only half of something or a quarter of something. I'll be covering modeling techniques in later tutorials, of course. Now let's see what else would be useful for us to add. So under mesh tools we've got stuff we use all the time: bevel, bridge. Let's put both of those on there. So bevel and bridge, two commands you're going to be using quite a lot. Now I use chamfer vertex, but not enough to in fact I use pretty much all of these tools, but we just want to put the ones that we use in sort of all of the time. So let's see, if we go under mesh tools, we also have multi-cut, which we use all the time. else? Mesh display, I'm often reversing faces. So that's about it for our menu so far. Now we will go ahead and add things to this as we go along, like duplicate special, for instance, is a very useful one. I'm just going to take the duplicate special options, as is center pivot and freeze transformations. Now this is the stuff that I use all the time. Like I say, if you wanted to chamfer a vertex, if you wanted to chamfer a vertex, you can just come in here, press shift, press right click, and the chamfer vertex is right there. So things like that can be left off. It's entirely up to you. It depends on what you use all the time. Obviously, if you've got the modeling toolkit, you can also get some multi-cut down here. For instance, many ways to do it. I like this shelf option. I use it quite a lot. It just optimizes my workflow. So what goes on here are things I like. Now, one last thing I wanted to show you. You can also put your own scripts up here. Now, creating scripts is beyond the purview of this little introduction to Maya, but I'm going to show you one that I use all the time. So I've got a script here, and this script here is basically going to move an object back to the center of the grid. So let's copy my script and let's go and add a new one to this. So if we go to shelf editor, we are in the right shelf. We're going to add a new script. It's just called user script. So I'm going to go move to origin and I'm going to save all shelves. Okay, so now I have this. Now you can add your own image, your own icon. I'm going to edit the script. I'm going to paste in, I'm going to edit the button, sorry. I'm going to paste in my script under command. It's a mel command. So that's it. That's it. I can change this now. Now, if I move this object and I want to get it back to the center of the grid, let's say I've got it all akimbo and I'm going to export it from this scene, and to do that I want it back to the center of the grid, I can now just push this button and back to the center of the grid it will go. So this is a highly useful thing. Now it would also be nice to be able to do that with a pivot point, which you can do manually. Hit insert to move the pivot, hit X to hit X to lock the pivot to the grid, and then just push it into the center of the grid. Now, why is this useful? It's useful because if we duplicate special around a circle, which we will be doing, in fact, let me just show you. So we can go up to our duplicate special options here. We can say, give us 5 copies of this object, rotate 60 around here and duplicate special, and you'll see I get my 5 copies of the object. Now, I could only do that by putting the pivot point of this in the center of the grid. So it would also be handy to have a button here that centered the pivot into the center of the grid, as well as the object. Because if I take, let's say, an object I create like this polygon plane and move it, then this one will center the object as well as the pivot, but we want something that just centers the pivot rather than having to hit insert, hit X and center it ourselves. So let's just have a bit of a scene cleanup here. And the command to center a pivot is this one. Okay. Now all this does is it gives Maya the name of the thing you've selected or multiple things you've selected. And then for each of those selections, it moves the whole object back to the origin. Now this is getting a bit advanced. I wouldn't expect, if you're new to Maya, you to understand this, but we're just going to create the buttons. You can download them from me, and if you want to get into some scripting to make your workflow even more efficient, by all means do so. So let's add a new button here. Let's go to shelf editor and plus, and this one I will call move pivot. Nice and easy, and I'm just going to click save all shelves, and that should give me another button here. So I'm going to edit this, and this will now move the pivot. But we need something slightly more than this. So if I edit the script I've already got, I'm going to copy this, edit here. Now don't worry, you don't need to know this progressing forward into the tutorial. I just thought you might be interested to see it, and we just need one of those. Yep. Done. And now I should be able to select a group of objects and move their pivots into the center of the grid. So let's close that. Let's make us some objects here. Okay, I'm going to shift select both objects, and that should move both of their pivot points into the center of the grid. Now, if I want to get the pivot points back where they should be, I can hit my center pivot button up here, and you'll see both pivots back. If I want to move both objects into the center of the grid, into the origin 0, 0, 0, there we go, we are done. This is handy when you are modeling and you have moved something out to match a reference piece or just temporarily, and you want to jump it straight back to the middle. Most handy. So, you know, there's tons of scripts out there. You can put any of them you want on your shelf. You can write your own. It's just all about optimizing your own workflow. So I would give these a name. So let's do our shelf editor here. And what have we got? Where have those gone? So user script. User script is not a very good name, is it? And we'll call this one move to origin. And we'll call this one move pivot to origin. Okay, obviously you might want to do a bit of a better job of naming, and you can also give them icon labels. Now I have to apologize for my typing here. My microphone is currently right in the way of my keyboard. So now we have some, you know, text on those. Easy enough, really. So it's going to move the object, and that will move the object's pivot. Okay, so we'll be adding to our shelves as we go along through the course of the tutorials we do here at SimplyMaya. I'll always make the shelf available to download, and of course please do set up your own things on the shelf. But really all you need to remember is hotbox instead of menus, your own shelf instead of constantly flicking through these hundreds of shelves, the hotkeys W to move, E to rotate, R to scale, and the hotkeys F8 for object mode, F9 for vertex, F11 for F10 for edge, and F11 for face. Alright, so I will see you soon, I hope, where we start to go over our tutorials and hopefully something that's of interest to you. So thank you very much for watching. Hi, welcome back. So let's dive straight in by creating a project folder for Maya. Now, this is something we would do when we start any new project. Even if you're just modeling something, this is something you should do. This will allow Maya to create its own internal directories so it knows where to store its data. So if you don't do this and then you reopen the file, you have some textures on it, you have some dynamics data that's been cached, all of that's going to be lost. You're going to have to go around and manually load it all in every time. It's a complete nightmare. This will also give you a room to store your texture files and source images, which is the directory that Maya looks for them, and store your reference in images. It allows Maya to be organized and you to be organized, and this is definitely something you want to speed up your own workflow. So hit new, give it a name, which I've already done, give it a location on your hard drive and click accept, and Maya will go and create all of this for you. Now, once that's done, I want to talk before we start about scaling within Maya. Now, by default, it comes in on a linear unit of 1 centimeter by 1 centimeter. So this grid is 1 centimeter by 1 centimeter. Internally, Maya will see this as 1 meter by 1 meter, regardless of what you have it set. So if you do a Bifrost simulation, to Bifrost, this would be 1 meter across. Now this becomes important if you're going to model in feet and inches, because you're going to have to convert your scene into metric at the end anyway if you're going to do any simulation. You can also convert the base of what the simulation works in as well, but that has its own unique set of problems. So if you can work in metric, work in metric. It's standard within the industry. If you're going to work, most big studios will swap files in metric. So, you know, it's a good habit to get into. If you want to change your working units, you come up to preferences, settings here, and you'll see mine is set to centimeters. You can indeed set it to a lot of things, but remember, that will be for your convenience. Maya will still be working internally in metric. All right, so now we've got that done, let's jump in and bring in a reference image. Now I'm going to bring in a reference image on an orthographic view. If you've got a secondary monitor, you might just want to shove it over there. However, bringing it in an orthographic view will let me zoom and pan around it. For the tutorial, it will be easier for you guys to see. So I'm going to create a panel here. I'm going to tear it off. I am going to go and set my panel here to top view, because the top view is fairly handy. And then I'm going to load in my image plane. So image plane, import image, mine is in the images directory, and we've got this room base image that I can now use my standard zoom and pan to have a look around. Now, one of the most important things for realistic rendering is scale. I've seen so many renders go wrong because people get the scale wrong. So they'll have a bed that's around 2 meters, 8 feet or whatever, and then there'll be a chair in the background that's huge. It just looks wrong, and it really is difficult for your eye to distinguish these discrepancies. So you do need an accurate set of measurements. You should always be working to a real world scale. You know, it is a bugbear for a lot of people. They end up with a scene that's out of perspective and out of scale. You can't really tell what's wrong with it, but you just know that there's something wrong with it. So in order for us to avoid that, we're going to make certain assumptions about this scene, and then we're going to check those assumptions by matching this photography shot with our scene to see if they line up. If they do, we can be fairly assured that our assumptions are correct. And we also have, in this instance, the internet to help us, to tell us the standard height of door frames, the standard width of king-size beds. So we can match, you know, fairly accurately. Now, one thing that's going to throw you off is sort of the focal length of the lens that was used to shoot the image. This seems to have been done on a fisheye and if I try and match a fisheye lens, say 22, 24 millimeter, with Maya's standard 35 millimeter camera lens, I'm going to end up with problems. So let's first build some things based upon our assumptions. So a 2 meter by 2 meter bed. The other reason you want to build some things before you start to try a match is because once you get inside a room within Maya, it's almost impossible to tell what scale you're working at. So if I just create this cube as a room, so here's a box standard room. Let's make it a bit narrower. Now I'm going to flip the normals on this, so when I go inside it, it's not pitch black. Let's just go to our shelf and flip those normals. So I'm going to go inside the room, and here I am inside the room. Now the grid is telling me that this is 1, 2, 3, 4, 5, 6, 7, 8 centimeters, and so on and so forth. And if I scale the room, there's kind of no sense of how big it is. Like, it doesn't appear to be getting that much further away from the grid. So I'm looking at this and I'm like, okay, that's my room, and I back out from the camera, and then I'm like, okay, it needs to be a bit thinner. And I've seen so many people try and set up rooms like this, and they're a bit wider, like so, and they get the camera where they want it, and they finally do the scene measurement, and this is 4 miles long, you know, 7 kilometers long. So this is a bad way to do it. You need to first off make some assumptions, and in order to do that, you need to give your own eye a reference point. So if I were to create a 2 meter by 2 meter bed somewhere around there, so let's go into the inputs here, and let's make this 210 maybe by 2 meters, and let's zoom out a bit. And these old beds tend to be a bit taller than modern ones, so I'm going to start off with the assumption that it would be 70 centimeters. I'm then going to use this view here to just move this off the grid. You know, I'm just going to move it off the grid a little bit. If we look at our own reference, you will see, don't need that, you will see here that the bed is a little bit off the floor. So now we've got something that's a visual indicator. You know that this is the size of a bed. So if your room appears to be several hundred miles that way, you'll know you've got it wrong. So let's refer to the reference again and make several more assumptions. Now, if this is the bed, I can pretty much say that that looks to be about 2 meters away from the wall. So if we go 2 meters here, 2 here, and more than 2 here, we would say that this would be 7 meters, 8 meters maybe. Across. Now that is just a guess. So let's do 8 meters by 8 meters to start with. So we'll come in, width and height of this plane, 8 meters by 8 meters. There we go. And we know that this should be about 2 meters out. So somewhere along there, and we can be pretty sure that the bed is smacked towards the back of the wall. So this is our first assumption. Now, we're also going to assume that this has a ceiling, which would be about 3 meters, 3.5 meters. Now, again, it's a guess, but that's all it needs to be. So let's control duplicate this and shove it 3 meters, let's say 3.5 meters up in the air. This is a fairly generously appointed hotel room here. So, you know, that should seem about right. Now, let's give ourselves a wall. This is not how we make the final room, by the way. This is purely for our reference here. And let's scale that wall down so it's a bit more reasonable, matching the floor and wall here. And I'm going to put another wall on the other side. Now, again, you wouldn't do these walls like this because they have no thickness, and a real world wall obviously will have some thickness. This is just to help us match our camera. So I'm going to come in and do it here. You could have done this with a box as well, but I find this slightly more convenient because then I can move all the walls and the floor independently when I go to match the shot. Now, for the shot matching, we will need... let me take these and shove them down a bit. In fact, let's scale them so they're about right. It's going to make it easier to see when we are on camera in a minute. There we go. Now, for this, we can assume that we're going to need another camera because we're going to need to change the focal length, and you don't want to be modeling in Maya with a sort of fisheye lens. It will make everything more difficult when it comes to looking around perspective view. So let's go to create camera, and we're going to go up to the attribute editor and we're going to give this camera a name. We're going to call it shot cam. Anything you like will do, anything you remember, and then we go to panels, perspective, and change over to the shot cam. So again, the shot cam is going to work the same way that any other camera in Maya works. I'm going to flip on the wireframe unshaded for the shot cam. This will make it a little easier to see what's going on, and then I'm going to drop the reference in here. So image plane, import image, and ours is under the images directory, and let's drop in the reference. Now I can't see through it, so let's change the alpha gain. Now I can see through it, and now it's just a case of matching everything in the reference, or the things that we modeled, like so. Now you can see here with our bed sort of matched, our room is completely out. Look, that is not following that at all. That's all akimbo, and as I said, that's probably due to the focal length on the lens of the camera. So let's make our camera a little more fish-eyed. So select your camera either in the outliner or by clicking this icon here, and let's make this a little more fish-eyed. So let's say 24mm. Be a fairly decent fisheye lens, and let's move the bed back in here, get it to a right sense of scale. And this is most certainly a trial and error process. So what have we got? We've got a roof that's a little too low, but that's fine. Our floor seems to be in. If I look at this piece here, it is actually coming along the dado rail. The thing is, we are a little bit out here, so let's go this way. Okay, now that's precisely matching the dado rail. This bed seems to be a little low off the floor. There we go. And the roof seems to be a little low, so I'm going to get that on my other camera here. So let's just bring in the perspective camera, and I'm going to move the roof up just a little bit. Okay, so the roof would be around here. Now, I think we made this roof sort of 3 meters 50, so there is a very good chance that this would be higher. Now, this coving across here, although it looks to be on the back wall, it's not. So it's not actually a good thing to match against. A good thing to match against would be this line here, and we're pretty well on with that line here. If I bring this up, this is pretty much matching our ceiling coving, and the bed is pretty much matching. Now the covers are overhanging, so you're going to see a little bit of that. Our floor is almost matching the floor here, I should think. Okay, and this is pretty good. Now, between this part and the next part, I'm going to spend some time just tweaking that. I might play with some focal lengths, so I might go to 23 or even 22 or up to 25. This is a bit of time-consuming process, but you can see we are pretty much almost matched here. If I move that, it almost matches this. It's a tiny bit out. If I move it down, it almost matches a tiny bit out. If I move it across, it seems to match the vertical really well. And I move it across here again, it seems to match the vertical really well. Now, there is a quick sanity check we can perform. So if we come in, we can see how high our ceiling is, for instance. Now that's almost 4 meters. So do we think this would be almost 4 meters? Whoops. And I move the camera. So if you use the angle bracket, left angle bracket, you'll move it back. Now, before we do that again, let's hit here to bookmark our camera. And then if I accidentally go like so, I can actually go back to the camera bookmark. All right, so I'm quite happy with this. I'm going to do a quick sanity check. So 4 meter ceiling. 4 meter ceiling might be a little bit too high. So I've noticed though that my ceiling up here, it is in fact a little bit off the line where we would want it. So I'm going to move it down here, 3 meters 60. That seems a bit more reasonable. Now, another sanity check we can do is we can cut out this door. We know these doors should be around 2.5 meters. And, you know, we know they probably should be around 180 wide, because you know yourself, you know, the width of an interior door. So let's see if we can put the money where the mouth is here and cut out this. And I'm just going to go into face mode here. F11 on the keyboard. And I'm going to cut a whacking great hole out, approximately where this door would be. Now, if this is in scale, I am good. I am golden. If this is completely out of scale, well, we've got a problem. Okay, and let's also check. The bed would be fairly far away from the back of the room. But it is, because it's got curtains and stuff behind it, so that looks all right. Now let's measure this door. So I'm going to hit Control-1 to isolate the camera, and I'm going to hit F. I'm going to make that bigger, and we are going to hope that this would be around 2.5 meters high, maybe a little higher. So create, measure tools, distance tool, click here, approximately here, and it's 2.5 meters high. How wide is it? It is 170, 180 is what I was going for. So we know now that we've got our you know, basically our ducks in a row. Now, as I've said, this coving isn't matching here, but that's fine because this coving is actually not against the back wall. So it's a difficult thing to match. But again, if we do take a look at this wall, you can see that this is pretty close to this. We might need to rotate the camera a little bit. So when we come back in the next part, we'll take a look at actually building the room itself. Because we've got the scale, we'll be able to quickly build this room, fit all the doors in, all the window holes. We now don't have to measure everything. You know, you don't have to create the measure tool every single time you want to get something done. You can simply cut the holes based upon your visual reference. So I hope something of this has been of interest, and now we've got a good base to work with. I will see you in the next part. Hi, welcome back. Let's dive right in. Now, before we start modeling the room, there's one thing I want to point out. If you think that skipping this step because it's unnecessary is a good idea, I'm going to show you why it isn't. So, I would estimate the length of this corridor, or the width of this corridor or small room here, would be about 3 to 3.5 meters. So if I put a reasonably scaled piece of furniture in there, like this table, and then I push that table up against the back wall, if it was closer, it would appear bigger, of course, just a perspective thing. Now, that means if I get the distance of this wrong, the width of this wrong, everything I put in there would have to be scaled to unrealistic proportions to match the photo, and that gives you the issue of things not looking real. So let's select our floor plane here and give it less subdivisions, because we only actually need a couple. And then I'm going to push this back until it hits the wall back here. So somewhere around there. Now, I would have said 3 to 3.5 meters. Let's measure it and see how accurate or inaccurate I would have been. So let's go from the top view. Let's just hide the roof here a minute because it's not necessary. Let's flick on the wireframe on shaded. Whoops, that would be the gate. Here we go. And let's measure this. So we need to measure from here to here. Now remember, my guess would have been 3.5 meters. I might still be right, but I could be massively out. So let's go to create, measure tools, distance tool, and just measure from here to the inside wall. And that is almost 5 meters. So I'd have been way out. Any furniture I put in there would have looked wrong. I'd have ended up rescaling. Now I'm just going to check this floor plane to make sure it is in the right place, and maybe it could come this way a little bit. I think I've clipped a skirting board there, but it's still going to be around 4 meters 70 maybe. Okay, let's do this so we can hit the vertex mode on this, F9 of course, quicker way to do it, and let's just pull that out there till it matches. Now we need to work on this as a floor plane, so we need to give some walls some thickness. Now in order to get the right thickness, I actually googled interior wall thickness, and in my case I measured mine as well. It was approximately 9 centimeters. There's quite a bit of leeway on this. Now I'm going to bring in a cube and I'm going to size this cube to 9 by 9 centimeters. So let's go under its inputs and 9 by 9. There we go. And now I've got a handy cutting guide. Now, obviously this is not going to be terribly accurate. It doesn't need to be. If you're interested in sort of extreme accuracy in Maya, I have a tutorial on the site called Maya for 3D printing, where we run through how to create very accurate measurements with Maya. Let's go to our shelf and hit the multi-cut tool, and then we can just cut across this handy guide. Now, as I say, doesn't need to be perfect. We are not, engineering a rocket ship here. We are simply doing a floor plan. So if it's 9.5 centimeters, it's not going to be a thing. Let's move it up to this interior wall. Hit F to focus on it so I can get it into shape here. Let's get it about in the middle of that. And let's cut some edges. So I'm going to hit Q. I'm going to cut my edges by first selecting the right thing. There we go. And let's just go into the multi-cut and start to cut here. So my multi-cut's got stuck on something else. Come on, multi-cut. There we go. It can be a rather annoying tool, the old multi-cut tool. And I'm just going to zoom this out here, and I need to cut one more wall down here. So Q, H to go into component mode, select my measuring cube and drag it across the screen so we can cut the wall here. Then we'll extrude these walls upwards and we'll have one nice convenient room. So making sure we select the right object. See, we do learn. There we go, and we are done. Now I'm probably not going to need this measuring cube, so I'm just going to get rid of it. In fact, what did I just get rid of? Let me flip into perspective view here and make sure I haven't just deleted something essential like the face from the corner here. So F8 and no, I did not. Thank God for that. Right, now this is superfluous to requirements. This is superfluous to requirements. I don't need the measure. Do not need. And the polycube, let's do a bit of tidy up. It's good to tidy as you go. This will now be the main room. And shot cam, polyplane 2 is the ceiling. So if we look at the ceiling height, it's about 380. To need this now, we're going to select these faces. Just go all the way around. And this one in the middle here, make sure you get them all. You don't want only half of them. That would be a bit of a disaster. We're going to hit Control E to extrude. We'll extrude the gimbal from the center and we'll go up, let's see, 3.5, 3.8, 380. 3.8 meters. Okay, now we'll check our perspective, our shot cam. Yep, and I would say we are about correct. Now, little tweaks could be done with this. Certainly it's not a perfect match, but it is good enough for our intent and purposes. It's good enough to give us that scale, and it's good enough to make sure we're not completely out. Now let's cut a door hole here, and I'm going to show you we're going to run into some issues. So you can use the multi-cut here or the one on the modeling toolkit, whichever one is convenient. And I've just put a point in there that I didn't want. Let's make this view a bit bigger so you guys can see. Let's make sure we are selected here, and multi-cut, there we go. So I'm going to cut around the door frame. Again, you're not looking for millimeter accuracy. And then I'm going to cut around here. Now you'll see this one doesn't cut in the other room as well. So if we flip to this cam, you'll see I've got a cut for the door here, but I don't have one here. So let's turn on the X-ray, and let's come in and cut one approximately here. Now I'm also going to have that problem on the outside of the building. I don't have one when we cut a door through to the outside. So let's do this. Let's come in, and these should all be on the same level. So I'm going to go F9 to go into vertex mode. I'm going to select them all. Let's do a quick check, make sure we got them all. I'm going to hit R to scale, and then I'm going to scale them all together. When I can't scale anymore, they're all dead level. Now things like this are not strictly necessary. We're going to go into face mode here and make sure we don't have any internal faces. We do not. We shouldn't do. But nice to have some confirmation. You don't want internal faces inside the geometry. So let's cut the door out. Whoops, that's the hot box, don't need that. Cut the doors out, that's the doors cut out. And if we go off X-ray, we're going to run into a small issue with there being, let's see, no edge around here and no face around here. No face, sorry, not edge. So we want to go to edge mode, F10, double click, and bridge. Now we've got a bridge here, that'll do. Done. Excellent. Now we need to do the same here, but you'll notice that we do not have a face here to bridge around. So if we try this, it's probably not going to work. We need to select this edge, hit Control E to extrude one out to here, and then weld these vertex together. So I'm going to use the target weld for this. You can also just select both the vertex and do a mesh, edit mesh, and merge, whichever takes your fancy. Okay, so hopefully this will not do anything bad to our bridge. Bridge, okay, yeah. The bridge can be a little temperamental from times, bridge, and that's bridge nicely. We probably could have done this in one operation, but I'm just checking that nothing goes wrong. Alright, so there we have our door holes, and indeed there we have our room pretty much modelled. Now one thing we would need to do is cut the windows. So I'm going to just use this for reference because it's actually difficult to see where the windows would be. So I actually want my window, let's say put the multi-cut here, and okay, why are we on this view? Let's see. So I think the window should go around here. Let's see where we are there. Yeah, that seems about right, next to the bed. And then we would need another one around here. We're going to need to cut it at the right height, so around here. And you would also have some left over around here. Now I'm going to put a lip around the outside as well, for the same reason we did last time. So that should be our window. Now let's straighten up these top vertex up here, and let's put another one here, just in case we decide to cut any windows in this room for lighting purposes. Now I'll want to use the side view, Q to go into selection, F9 to select the vertex, and I want to select all of these. Let's make sure we've got them all. We have, let's check the other side, so R to scale and scale them together. So you can't scale them no more. Now I can cut out my window, which I believe I actually want to make a bit wider than that. So we've got it all, and now we can just move that edge loop a bit closer to the bed. It's difficult to see on the reference because the pillar is of course in the way. Okay, now we should just be able to cut our faces. So one here, one here, one here, and one here, and delete. And we will need to bridge across that the same way as we did before. So making sure we are edge mode, and bridge, and we are done. So let's cut that one window. Now let's cut the other windows. So we're going to need the multi-cut tool, and let's go into this view proper, multi-cut, here we go, and cut from here. Now this one I'm going to eyeball because it just needs to be around that big. I think we're not going to see it, it's not going to be on camera, so that's possibly a bit too big. Not an issue. Just move it across and cut the holes for it. So done and done and done and done. And that's that window out there. So we are pretty well matched. In fact, we are so well matched that if we look at the door, we cut this door frame. Let me turn the X-ray off for a second. I actually want that wireframe unshaded on. Okay, so let me go out of face mode into object mode. All right, if we look at the door frame we cut out here, if we look at the door, that's also got the same door frame cut around it. So in real life, when you're modeling this building or building this building, these doors would have been, you know, one running through, and because we have everything matched, we have the same progress here. So that's it. That's basically all there is to it. We've got a well-matched room, and now we just start putting things into it. Now, I would say that we don't know how long the room is in this direction. So we have no idea. I mean, this room could be ginormous. It could go all the way out to here. We also don't know how long it is in this direction. So this gives us a bit of artistic lighting, license. For lighting purposes later on, we might make it bigger. We might put windows over here, windows over here. There would definitely, I would think, be some windows in this room. So when we get onto the lighting portion of this, we shall cut in some windows. Let's just bring the roof back. And I normally leave this hidden, Shift H, simply because it's not necessary. Now, again, we've got way too much, too many subdivisions on this, but I have cleared it. I must have duplicated it from somewhere else. So rather than using this for the roof and making everyone's life difficult, I'm just going to take a new plane and scale it up, give it 1-on-1 subdivisions. If you duplicate something without its input connections, you're no longer going to have access to its inputs. That sounded extremely obvious there where I said it out loud, but it is true. So if you are duplicating objects, remember you can duplicate special with input connections should you need to. In a case like this, I mean, this is honestly no hassle, and on goes our roof. So there is our room. And as I was saying, you know, if you took the bed out of this, your mind instantly recognizes bed, you know how big it is, you know, because you get into one every night, presumably. So without this, you know, your scaling can go terribly wonky. Okay, so thank you for watching. I hope you got something out of this part, and I'll see you in the next one. Hi, welcome back. So now we've done a few things with our room, let's talk about modeling reusable architectural visual or set design components, by which I mean things you're going to use in pretty much any modern interior: coving, skirting board, plug sockets, light switches. You'd be surprised at the number of people that forget these things, and it really does give your scene a hint of extra realism to see them around. I'm also going to take doors, door handles, screw heads for fixtures and fittings, all of this kind of stuff. Now let's first start off with a completely new scene, and in this scene I want to discuss polygon modeling, specifically beveling versus smoothing, what to do and when to do it. So let's start out by modeling a very simple skirting board profile. And before I do that, for those of you that don't know what smooth preview is, or smoothing a model in Maya, let me explain very simply. So if I take a cube, Maya is going to attempt to smooth between all of the edges. So this would smooth into a circle. Now you get to see the smooth preview by hitting 3 on the keyboard, and as you can see I have smoothed in to a circle. If I wanted to stop this smoothing from happening, I'd have to give it an edge to smooth to. So if I put one round the top like so, and then I'm going to stop that smoothing, I'm going to stop that smoothing, stop that smoothing, and stop that smoothing. When I smooth now, I would expect a nice, crisp, slightly rounded, beveled edge across the top, which is, of course, exactly what I get. So when you see people modeling me and I'm putting in these edges, what I'm attempting to do is stop the cube smoothing too much, and where I put these edges will absolutely control how much is smoothed. So if I go into the smooth preview and I grab this edge and I move it down, you'll see that I start to get a bigger smooth along this corner. Okay, so I am much more rounded here than I am down here, for instance. So you can absolutely control how smooth or rounded a model is going to be by smoothing it, and then it's the placement of these edge loops which will control the amount of smoothing. So let's look at another way to do this real quickly. I'm going to select my chappy here, I'm going to get rid of it, and I'm going to bring in a new cube. Now, what if I wanted to do this and I didn't want to smooth this object? Because when you smooth geometry, this is the preview of it. There is actually more geometry there. If I go up and do a mesh smooth, which is here, you can see that actually is creating more divisions. So by smoothing the geometry, you're getting more to work with, your geometry become more complicated. What if I just wanted this, but I just wanted a hard edge on it that wasn't razor straight? Or I just wanted to make a small groove, like a small curve on the top. In that case, I can select all the edges and bevel it. Okay, now I'm going to do quite a few segments here, and probably a much smaller fraction. And you'll see that I get here a nice beveled edge on my cube, and there is now no need for me to smooth it. And again, you can control the bevel with the bevel tool, which you will find here. So if I wanted, I could do a 0.05, and that would get a lot smaller, and I'd get a nice crisper edge. So that's the difference. You can bevel a model, you can smooth it. There are other techniques for doing this, of course, but those are the two main ones. So you've always got to make a decision between whether you want to bevel the model, whether you want it smoothed, whether you're modeling it in separate parts, and what's what. So now with that brief explanation, and I hope that made sense, and I hope that's been helpful to you when you've seen various models and you're not quite sure why one is done in one way, let's bring the grid back here and let's import a fairly simple skirting board profile into this view. So I'm going to make that a bit larger. I don't want to be modeling microscopic things, and I'm going to move this into the center. Now, generally speaking, you want to move your reference rather than moving your workpiece. You always want your workpiece to be on the origin of the grid. That way, if you add anything else to it, it's going to be easy to line up. As we tackle more complicated modeling issues, that will become apparent. Now, I just hit E to rotate, and I press and hold J to lock the rotation in 15-degree increments when you rotate. So I'm going to make this a bit bigger, and I'm also going to take away its subdivisions. Now, you want to work on as few subdivisions as possible. Flip on the X-ray so we get a better look at it. This picture is a bit bright for me, so I'm going to turn down this, and I'm probably going to turn down its opacity too a little bit. There we go, and that's not central, so let's just move it. There we go. Now I should just be able to scale down my plane till it matches the reference, scale it up, and we are done. Needs to go up a little bit up here, so let's just grab the verts and go upwards. And now we're going to need some edge loops cut into this so we can start to shape the geometry. So let's just add a multi-cut here to do for this one, here, here, and here. I'm also going to need one here to control this curve. So bang it down there, and then I've got some edges that are superfluous to requirements here. So F11 to go interface mode, Q for the selection tool, and get rid of it. So if we look at this now, I'm actually going to move this model off the axis because I know I'm not going to be adding anything to it. In fact, let's not engage in bad practice. Let's just hide this. And I don't need the grid anymore either. So I've got this, and obviously it's a bit one-dimensional. So let's grab the edge of it and extrude outwards, other way, so we don't get the normals reversed. And what I've got here is a skirting board without that nice rounded edge here. Now I could smooth this, and that certainly starts to give me the nice rounded edge, but the rest of it sort of disintegrates. Now, because this is skirting board, I actually don't need the back faces or the side faces. They're going to be embedded in the wall. You're never going to see them. So let's take these out. Don't need any of those. Don't need any of these either. I'm going to keep the bottom face and the top face. And I'm going to hit 3. And you'll see that that's smoothed across, but so is everything else. So now you need to make the determination whether it would be easier just to bevel this one edge. In fact, if I go into edge, this one edge, or would it be easier to add smoothing control edges around every straight edge in the model, like so. Okay, and this is up to you. This is something you're going to have to determine. For me, if it's just one edge, like now I've got everything done nice and hunky-dory, that would probably do it. I move this vertex down, and this would need to be like so. Okay, there we are done. I think we would need to hold the bottom too, of course, so one here and one here. And there's all the edges we should need to control that. So that's one way to do it. Let's make a copy of it. So I'm just going to go to object mode, Control D, and push it out. And let's do one that isn't smooth, but one that's just crisp. And then you can see the difference. So I'm going to go to edge mode, and I'm going to remove all the edges that I just put in, which shouldn't take more than a second. Double click to get them all. There we go. And I just want you to see the difference. So I'm going to hold the shift and right click and hit delete edge. That way the edges will take their vertices with them when they go. And that's back to the native model that we had. So if I don't want to smooth this, but I still want to get something like this, you see these edges are nice and crisp here and nice and crisp here, and this is nice and round. Let's see what we can do with the bevel tool. So for now, let's shove this one a bit further this way so it's not in our way. And the first thing we want to do is put a big bevel on this. So let's select the edge and go to bevel, which we can find here. And I'm going to do some segments, and I'm going to move the fraction all the way to 1. And that's given me a nice round edge. Now that might not be high enough poly for you, but you can add some more segments. Now as to getting these crisp edges, we're going to need one here. Now when I've done a bevel at a fraction of 1, you might be able to see 2 edges here. So what I like to do when I've done a big bevel like this is merge this model. So let's hit F8 and mesh merge. Edit mesh and merge. Done. And we're going to merge with a very small threshold, and that should do us. You can check that your model is nicely merged and still quadded by just running an edge loop tool around it. Okay, so now I've done that, I can come in and select this edge, this edge, this edge, and this edge, and do another bevel. But this time I want a chamfer. A chamfer is just a bevel with one segment. So I want a nice small chamfer here. There we go, like so. And that should do it. So let's go into object mode. and click away, and let's put our profiles side by side and see what is what here. Okay, so they both catch the light nicely on the edges. They both have a rounded profile. I would say this beveled one, however, is less geometry. It's neater. It doesn't need to be smoothed, and I think it catches the light a little brighter, a little nicer. Now, we could, of course, come in here and edit our smoothing control edges to get them a little tighter. But in this case of bevel versus smooth, I'm going to say bevel is a clear winner here. So you'll have to work out what stuff you want to smooth and what stuff you want to bevel. Now, if it's real hard surface stuff with, you know, very few curves, generally I'd recommend that you bevel. If it's more soft and organic stuff, then obviously you're going to want to smooth. So I'm going to get rid of the smooth version of this. Hopefully that's given you some insight into bevel versus smooth. And we can actually get a poly count on this. So I'm going to turn this off smooth preview, and I'm going to go to mesh smooth. Okay, there we go. That's smooth with one division. Then I'm going to turn on my poly count. So this is now smooth geometry wise, not just a preview. I'm going to go up to window UI elements, and I'm going to turn on, actually it's not UI elements. I'm going for display, and I need the heads up display. Heads up display, there we go. Polygon count. So I'm going to click this one, and it is, let's see, 20 faces. I'm going to click the smooth one, it's 152. So this object is substantially smaller than this one. And I would say this one looks better as well. So again, just a decision for you. I just wanted to take you through that different type of workflow, smooth versus bevel, for this kind of hard surface modeling. So I hope that's been of interest to you. When I come back, we're going to tackle a NURBS workflow. So this would be a polygon workflow, smooth, beveled, hard surface versus a more smooth surface. And in the next part, we're going to tackle a curved based NURBS workflow. All right, so thank you very much for watching, and I will see you in the next part. Hi, welcome back. So let's just hide our previously made skirting board here, and we'll just get rid of our image plane. Now we're going to come back in and sort these objects out for export, because you don't want to just be exporting them in the middle of the scene. There's a specific way you're going to want to export them, which we'll go over in a second. Now I'm going to open another image plane, and we're going to look at something that's far more complicated to make. And we'll use pretty much a different workflow altogether. So I'm going to come in here, and for this is a much more complex curve here. So I wouldn't do this with a polygon, although you certainly can, the same way we did the last one, just cutting your edge loops in and then either using a beveled workflow or a smoothed workflow to get these curves. That would do. I want to show you a different way of doing it. So we're going to use the Bezier curve tool here, and people don't like this tool for the same reason that they don't like it in Photoshop, because it can be somewhat complicated to use. So I'm going to click a point here, I'm going to click a point here, and you can come in and move these points about, that's fine. So get it nice and straightish. There we go, straightish, close enough for this type of work, and continue to click your points and straighten them up. Now I would say if you accidentally click away from your curve, you can go back to editing it just by clicking the Bezier curve tool again. So click the curve, click Bezier curve, select the last point in your curve, and you can continue to add to and edit your curve. Backspace, by the way, will delete a point if you've put one in the wrong place. Now, talking to this, I am going to do the same trick with this image plane as I did with the last one. It makes it much easier to see what we're doing here with this. So Bezier curve, straighten this one up because it's a little crooked. Actually, this is not going to matter that much that it's a little crooked, just does my OCD. There we go. So how Bezier curves work. Let's put a point here, and let's say a point here. Now it's not very curved. If we come back up and we hold Control down while selecting the point, we'll be able to pull a curve handle out. which will allow me to do all sorts of interesting things like this. Now, if you want, you can break the tangent on these, should you need to, if you have a kind of a weirdly shaped curve. So that's just holding control. If you just click, you're just going to move it about. If you hold control, you will then be able to play with the handles. You'll be able to pull the handles out of the curve. So let's continue to go. You'll need to click on the last point. So again, if I click here and then say here and hold control, I will then pull out that curve handle, which I can then use to do this. So again, last point in the curve, I'm going to click down and across to here and follow it round. So as you can see, not terribly difficult to use the Bezier curve tool as soon as you sort of understand the basics of it. That's a bit far forward, isn't it? Yeah. So control, get a nice curve, come down here, and we can build a very complicated curve with this method. So what sort of curve have we got here? Somewhere around here, I would think, and then down to here, and then control, whoops, and make our curve. There we go. So click the last point to continue editing here and here. I'm just going to do this in one go, and there we go. And around about there, and press return when you are happy with your curve. Like I say, if you want to go back and edit it a bit more, you can simply make sure it's selected, hit the Bezier curve, and this will allow you to come back in and edit all of these points should you need to. Like I immediately noticed this one's a little wonky. So there we go. Spend as long of that as you need to. So let's click Q, and now we have a curve, but what we don't have is any geometry. So I'm going to duplicate the curve, hit W, move it out here. I'm going to move this plane away from the origin. We don't actually need it in the origin. And then I'm going to click one, shift click the other one, go to surfaces and loft. And that will create a surface between them. If it comes through black on this side, by the way, instead of on the back, click the surface, click the hotbox, surfaces, reverse direction. In our case, that wasn't necessary, but this often comes through the wrong way around. Okay, now we have this surface. This is great, but it's a NURBS surface, not great for us to render. We want a polygon. So just go to Modify, Convert, NURBS to polygons. I'm going to pop over the option box, and I'm just going to do this on control points. I'm going to hit Tessellate, and you will see that has given us a polygon object that if we smooth, should smooth into an exact likeness of our object. So let's hide our lofted surface and our curves, and let's go Control H to hide those, and let's look in our viewport and see if we are indeed the same curve. So let's hit smooth. So we're using a smooth workflow here, and we have pretty much nailed it. I think there's a few bits here and there that could do with some editing, so just grab the vertex and move them into place. And yeah, I'm going to scale these verts in because that's not very rounded, and this is not very rounded either, so it's had a problem with those, but there you go. I mean, it was close enough. Okay, but there is an issue. I see three vertex very close together here, and if I select that and then select the vertex and then hit 1 to go into non-smooth, it all goes back to one vertex. This is very bad news. That's three vertex sharing exactly the same point in space. And now we've looked at a smooth workflow, we know that this edge and this edge, so this one and this one, should smooth together when I hit smooth, and they don't. So we've got some hinky geometry here. We've got some non-manifold geometry. We've got geometry that we just can't put up with, basically. It's bad practice. It's going to come and bite you later on. If I try and run an edge loop through this thing, let's try it. So let's just get here. We can just about do it, but we do have those edges that are all together. In fact, if I do a vertex face, you can see the edges I'm talking about. So it's an edge here, edge here, edge here. There doesn't appear to be any faces connected to them, and that's generally a bad idea. So let's go into object mode, and for a start we do not need this edge and we do not need this edge. They're not doing anything, so let's come in and delete those edges. Just make this as simple as possible, and we need to sort this geometry out. So even if this would pass muster, I would never give this to somebody else. It's going to create problems with UVing. It's going to create problems if we need to model it. So let's fix it. So easy way to fix this: select the object, do a mesh merge, edit mesh merge. Okay, and that's going to merge all of those things together. So when I smooth this now, you'll see it smooths like you would expect it to. Problem is that that does not match our thing anymore. You know, it's none of our nice hard straight edges are in. So we can come in now and we can put some smoothing control edges on this. Now, I don't want to spend the time doing this manually. In fact, in this case, this would be rather easy to do manually, but let's do it another way. Let's do edge. So I'm going to select every edge I want to remain straight. Edge, edge, edge. Let's see here. This is definitely going to remain straight. This and this are definitely going to remain straight. This is going to remain straight. This and this, I believe. Let's see down here. Yeah, this one is to remain straight. This one is to remain straight. This one is to remain straight. So when you've got all the edges that need to remain straight, okay, this one and this one too, I think, which probably means this one will, we can just do a edit mesh bevel with a very small fraction, like so. And now when I smooth this, you should see that it remains, let's go into the proper view. Should see that the straight edges remain straight, and where it should be curved remains curved. So this time we didn't use the bevels tool to create the smooth, we used the bevel tool to create the nice crisp sharp edges, and I see here that I could probably do with some help on the top of the model. Okay, so I'm going to come in and modeling toolkit and just cut an edge for myself. Whoops. That's not what I wanted at all. And hit 3, and yep, that's much better. So basically we are done here. Let me just check the view. See if we've missed anything. Now there's definitely some points to be adjusted. Let's go into vertex mode. Okay, I'm not liking this here. So let's select that vertex. Drop out here and see if that vertex is connected to an edge. Yep, that's an edge I do not need. So I'm going to delete that. There we go. That's smoothed that round much nicer. Do we have anything else? I don't think we actually do. Okay, I'm going to get a vertex here, F9, and I'm going to pull this down so it's a bit straighter. That seems to be following a nice curve. Yep. I think I'm going to call this good enough for a profile. So this creates our coving. Okay, so this one would be smoothed as opposed to simply beveled. And again, it doesn't need sides or a back because it's going to be smushed into a wall. Let's just multi-cut around it to make sure that we still can. We still can. So we are all good to go. So you've seen a couple of different workflows now, how to start from a polygon, how to start from a curve, and then convert to a NURB, and then from a NURB back to a polygon. Remember, when you're converting for NURBs to polygons, you need to be checking your work, checking your geometry. So I'm actually going to come in, I'm going to set this back to object mode, and we're going to get these things ready for export. Now, I want mine to be in the center of the grid. Let's just delete this image plane. And I don't want them to have any history on them. So I'm going to call this coving, and I'll bring this back, and I'll call it S-board, so I know what I'm dealing with. And then we need to get these things ready for export. So if I hit W right now to move this, you can see the pivot point isn't in a good position. Now I want the pivot point of this down the bottom here. So what I'm going to do is hit insert to move the pivot point, and then I'm going to align it to this edge here. Then I'm going to insert again to stop with the pivot point. The reason I'm doing that is because when I move this into the scene, if I want it to be bigger, it's going to scale from the bottom, which is exactly what I want. So once I've done this, I can use my move to object origin, and we will go like so. Now, I do not like the alignment of this pivot point. Let me just modify center pivot. Okay, that pivot is just aligned all manner of wrong. So let's hit insert and align it up here like so. Done. And then just move it to the bottom of the object like so. We don't need to be super accurate. This is just going to help us later on scale the object. Insert, and I am good to go. Now I'm going to do the same with this. So first off, I am going to modify center the pivot. Then I'm going to scale this one from the top because I'll be putting it on the roof, so I want it to scale from the top down. I'm going to go like so. I am going to put the pivot point here, so insert align to this. And then once again, I am going to just make sure my pivot is right at the top, like so. Done. Insert. Done. And now when I bring this into a room, if I want to scale it, it'll scale out from the top. The top will remain where it is. So we need to put this one in the center of the grid. So move to center. There we go. There is our coving and our skirting board ready for export. So that just denotes a couple of different styles of modeling. Polygon, no smooth, bevel, NURBS to polygon with a bevel and a smooth. Okay, so select both your objects and export these. File, export selection, and we will call this, I don't know, assets. Asset. And then we'll import these into our file when we are ready. We'll create an asset file or a library file that contains all of our goodness, skirting boards, doors, door handles, things like that. So we've got a bunch of reusable components ready to go anytime we need them. All right, so thank you very much for watching. I shall see you in the next part. Hi, welcome back. So before we jump into modeling something a little more complicated, I just wanted to show you this. This is the one we made. It has been smoothed, as we did last time, and smoothed it has 720 faces, which is not really so many unless you're trying to get it ultra low for a game, of course. Now this one, I just took the liberty to bevel. So this one has not been smoothed at all. It's on 1 on the keyboard. And I've used just the bevel tool with big fractional bevels to round out everything that needed rounded, and then I've just chamfered the edges. Now both of these look equally nice in my opinion, and how you would do this depends on the model. If you have a polygon limit, which normally you wouldn't if you were working on film, or certainly not one that mattered between 67 and 720 faces. But I'm going to leave both pieces of the geometry in there for you to have a look at. So I'm going to hide those, and I am going to go into my front view here where I've brought in a picture of this door handle. Now I'll leave all the reference in the project for you. I'm going to bring back the grid and just make sure your reference is central. Okay, so that's about as central as I can get it. Possibly it needs moving up or down a bit, but that's not really such an issue. And the reason I want it central on the grid is because I'm only actually going to model the top quarter of it to start out. So we're going to do the backing plate first, come in with a plane, scale the plane a little bit, E to rotate, J to lock the rotation, and whack it up. Now, if your reference is in the wrong place, it should go without saying. You want to move the reference, not the object. So, you know, don't move your object over here to fit your reference, move your reference over there. I'm going to say that again because it becomes quite important the more complex your modeling gets. So, F9 for vertex mode, and I am just going to shove this down to the center line and then across to the middle line. And you can actually hit X to lock that to the grid. should you want to be a bit more accurate, which is never a bad idea. Now I'm going to pull this out until it hits the edge of the very, very badly painted door handle here. And now we need to cut some edge loops in this to allow us to start forming a shape. So I'm going to put an edge loop right across this screw because I'll need a vertex here in a minute. Because this tutorial is going to be about cutting things out. Now, lots of people have issues with cutting things out, and it can be, to be perfectly honest, a bit of a nightmare. So let's get F9. Now we're going to start out with a relatively simple thing to cut out, which this is. But then again, cutting any kind of hole in polygonal geometry is always inevitably going to lead you to some issues. Which, to be fair, is why we are doing it. So we can see those issues and I can help you sort them out. Now here we've got bad geometry. We've got 1, 2, 3, 4, so we're still a quad, but we've got this vertex here. Now allow me to demonstrate how that's going to cause you a problem. I'm going to smooth this and this isn't going to move. That's not good. That's going to cause us issues. So if we come in and we multi-cut an edge loop around here, you'll see it doesn't go all the way to the edge. This topology is no good. It should go flow around. So let's fix it. Let's put an edge loop out here. Then I don't like this edge. I am going to get rid of it, delete edge, and I'm going to put another edge in. Now, before I do that, let me just dim down my background image here, just in case you guys are having some trouble seeing this. So here we go, that's all I'm going to need. Alright, now the model itself should be easier to see. Okay, so now we've got an n-gon, 1, 2, 3, 4, 5 sides. Now there's an easy way to identify n-gons. Let's go into object mode. In fact, let's go into face mode and select all the faces. Now, how do we know if one of these is an n-gon? We can, of course, count all the sides, but really, who's got time for that? So, select all those faces, go up to select, and you want use constraint, and then we want all and next, and n-sided will show you where there's n-gons. If you put it onto triangles, it will show you where there's triangles, and if you put it onto quads, it will show you where there is quads. So if I put that onto n-sided, this one lights up. It's a big fat n-gon, and we don't want it. It'll cause issues with smoothing. It'll cause issues with everything. Some triangles are okay. If you have the occasional triangle in a model that's not going to be deformed or is not essential to be animated, bent in a way, then you can definitely get away with some triangles, unless you would need all quads for some sort of simulation program or is required for an export. A couple of small triangles, don't worry about it. N-gons, always worry about it. So let's get our multi-cut tool here and cut up. In fact, I'm going to do this on this view. It's easier. It's going to be nice and neat here. Cut up here, here, and then let's just go off here. Okay, now this is a quad, 1, 2, 3, and 4, and this is an n-gon, 1, 2, 3, 4. So 1, 2, 3, 4, 5. Sorry, there we go. So cut across here, and now we're all quadded. If I smooth now, you should see this actually smooths. Okay, so something to be aware of. Always be mindful of your topology. Now, we need to cut a hole in this, but only one. We need to cut a hole here and here, but I want to mirror this so the screw is top and bottom. And if I cut this hole here, I'll also mirror the hole here. So I'm going to have to cut the hole, then mirror, then cut this hole. So let's go and take a look at a way to cut a hole in polygonal geometry. Now, this one's going to be easy enough, but like everything, it's easy enough once you've done it a few times. Now, let's grab this vertex, hold shift, right click, and chamfer the vertex. This gives us this kind of unusual shape here. This is not exactly what we want. And in fact, we want 4 sides on here. So I'm going to cut from here to here, and then from here all the way down to here. And in fact, you know what? That I didn't really like the way that cut, so I'm going to put a multi-cut in here and do this. This will give me a bit more topology to work with. Then I'm going to select the vertex, and then I'm going to chamfer it. Okay, now you'll see it's come in much more. It's not quite as stretched down here. I am also going to have to turn this into a hexagon, or at least half of one. So for that, modeling toolkit, or I could have just got it from the shelf, I'm going to cut and cut. It doesn't really matter. We're not getting points for neatness at this stage. That's all we need. Now, I need to turn this as hexagonal as possible. So I'm going to bring in a cylinder. I'm going to flip it into component mode. I'm going to flip it round. Just hold J to lock the rotation. I'm going to move it up here, and I'm going to make it the same size as this screw head, or, you know, a good approximation of it. Then I'm going to give it 8 sides. We're only using this for measuring. So this should be here, this one here, this one here, this one here, this one here, so on and so forth. Now, to make sure that I don't keep selecting this by accident, I'm going to go to Object and Freeze. Object Freeze. There we go. Now I can't select it by accident. So now I can edit my vertex with impunity. Now you only want to go on the y-axis here. You don't want to be pulling this out here. When you mirror it, you're going to come a cropper. So down here, this one over to here. Again, this as accurate as you can in a sensible sort of time frame. So that looks about right to me. I'm also going to cut an edge loop around it. So I'm just going to, in fact, we should be able to put an edge loop around it. Yeah, this one is not quite where I want it. So Q for selection mode, W, and I am just going to move that one a bit in like so. We are trying to get it nice and even. This will allow us to create a nice and even circular hole. Done like so. Now I will have a face in the middle. Let's unfreeze this. Another reason for the outliner, I can't select this or do anything. I can select it in the outliner and unfreeze it. I genuinely don't need it right now, so I'm going to shove it up there. And if we look at the faces here, I'm going to select this face and delete it. When I hit 3, it'll go round. Now the reason it's not completely round is you would need to complete the hole on the other side, which we will do when we mirror. But for right now, let's mirror this down and cut the hole for the door handle. So going into, let's see, F8, and we're going to mirror this, and this is going to be mirrored on -y. So let's hit our mirror up here, and we want mirror y, negative y. I'm going to put this onto bounded box or world, should be fine. And let's check that with our reference. Okay, looks pretty good. So we did in fact get the reference in the center. Now there we go. That is our object with the hole for the screw at the top and the bottom of the holding plate, or whatever you call one of these things. I am honestly not sure. I'm just going to check it against the reference again. I think maybe I would like it to be a little wider here. So I'm going to just grab these and move them out a bit. They're going to work. Just a tad. Plenty of time to play with that when we've cut the rest of the holes. Okay, now I'm going to need a bigger hole here. So same drill, really. Chamfer the vertex. Done. Then come up and add in the extra points we need. So one here. Let's try and get that as neat. Oh, press return when you finish cutting your point, of course, or you will continue to cut. So somewhere around here. Now I need my sizing cylinder to here, and we are going to cut this so it is about that big, I would say. So let's come in and freeze this thing again. Grab these vertex. There's that one and that one done together. And W, there we go. One here, one here, one here, Oh, and that one went a bit high up. Not to worry. Okay, there we go. We got some points for neatness there. Select our cylinder, unfreeze it, and just shove it out the way somewhere. Doesn't really matter where. There we go. And we know there's going to be a face here that we don't need. So let's get rid of it. Once again, let's cut a nice neat edge loop around. Like so, and like so. So this one's pretty good, and that should work quite well. Now we've got a hole for the handle and 2 holes for the screw. Now we just need a keyhole, which you can't see on here, but I'm just going to wing this one. Let me get my sizing cylinder. There we go. So I'm going to cut a keyhole around here. Now, there really is little need for us to cut this keyhole because we could cover it up, but let's just do it as an exercise. So again, chamfer. Let's see, what do we need? Multi-cut. Sorry, having a senior moment there. There we go, around 50%, done. Return, and same here. 50% done. I'm going to bring in the sizing reference. And how big would my keyhole be? Probably smaller than that, actually. So let's make it like so. Now let's freeze that and edit these vertex. Oops. I want to make sure that I only move that like so. Okay, done. Let us remove our sizing cylinder for the moment. Out the way, and get rid of this face. Done. Now we're going to need to cut in the square position for the keyhole. So let's cut down here. And this is no good either. This is going to affect my smooth on here, so I don't want it, but we'll take care of that in a second. First, let's go up here and figure out where we want our actual, slot cut for the key to go in. So I am going to multi-cut all around here. In fact, let me take that one out. Let's multi-cut all around here like we did in the other instances. Let us select some of these guys and let us get them nice, neat and orderly. Okay, so something around like so. Then let us put in the cut for where we want the keyhole to start. Now we're going to have this in here. This is nasty. This will dramatically affect how your hole smooths out into round, so we can't have it. So we have to get rid of the edge. I'm going to go to Shift, right click and delete edge. If I didn't do that, the polygons would, the vertex would stay where they were. So let's get rid of that edge. And now we have to multi-cut down here and just out to the side. So we have 1, 2, 3, 4, 5 here. So I can cut across and down. And now we're all quadded and we don't have anything interfering with this at all. So we won't be affected when we smooth too much. And I'm going to need to do probably not the same here because I'm going to be cutting this out anyway. So F9, vertex, let's move this guy like so. And how long do we want the slot for our keyhole? About this long, really, I think. So let's just go into face mode. And get rid of this, and get rid of this. Done. Okay, that would be straight, I believe. Let's straighten them up. Like so, and that cuts a keyhole. Now, let's do a quick geometry check. This is not good. Where it is, let's straighten it up a little bit. That should be a bit better. And let's just check this model for any n-gons, triangles, things of that nature. So as we've done before, not terribly difficult to do this. And I think the keyhole should be like wider down here. Yeah, if I remember rightly. I'll bring some reference in later and double check it. But for right now, we just want to cut the holes. So let's go to select and use constraints. Let's select all the faces, F10, F11, sorry, doink. And let's see, do we have any triangles? Okay, that all are next. There we go. So I am not selecting any triangles. Do we have any n-gons? That's the thing that concerns me, and we have no n-gons. So that is very nice. Okay, so I'm happy. We are all quadded. We look reasonably decent in the geometry stakes. Let's mirror this thing across. So this time we should be mirroring plus x. So let's come in and we can just use the mirror up here. And so we want x and plus, and there we go. Now we've got the merge way too high, so let's go 0.1. And there is our hole for this. Looks all right. In fact, let's do 0.05. You don't want the merge to threshold too high. So this is all looking okay. Keyhole's looking okay. Door hole, let's smooth it. See how we go. That's looking fine. That's looking fine. Okay, I am going to check that against the reference. Looks pretty good. So that's basically how you can cut holes in hard surface polygonal geometry, or in any polygonal geometry. Now let's give some depth to this thing. So I'm going to select this edge all the way around here, hit Control E to extrude it, and then I'm going to give it some depth. Then I'm going to mirror it across -z. In most likelihood, I think that should be. In fact, do we want to mirror this across? Because I'm thinking I could have a door handle on both sides, but that's not the way that works, is it? It is not. So, let's see, best way to do this, we can just bridge it, but that's not going to look very nice until we put some smoothing control edges in. So let's multi-cut here. In fact, this thing doesn't need a back side, does it? It's going to be shoved into a door, and I believe these things are hollow anyway. So yeah, let's go to the face. Don't actually need that. Let's smooth this once more. What I do need though is to take this edge, this one, because the holes need some depth. And I'm going to hit Control E. I'm going to center that, and I'm just going to pull these backwards. Really, so we have some holes in here. Okay, this object doesn't actually need any thickness to it, just by the nature of the beast, so that should be just fine. So there we go. There's a few tweaks we need to do with this. I would like to get it a bit thicker in the middle. If I just select this whole edge, hit B for soft selection, and then hold B and change the soft selection brush up just a little bit, hold R and get it just a little bit thicker in the middle. But all of these are kind of small, tiny tweaks. The main object was to cut some fairly complex holes in something like this, which I believe we have done. Now, we can also do this to help keep our keyhole from squashing too much. There we go, it looks a little better now. And do we need to do that with the door hole? Looks fine, and these look fine, but bear in mind you could, you know, control the edge smoothing a little bit with one in here, and then that would be one down here too. Okay, looks a little better. Alright, so when we come back, we will look at doing the handle for this. Now the handle is a little complicated because it's a hexagon going into a circle. Nothing we can't handle already. I am also going to, let's see, probably change this a little bit, some final tweaks and cleanup, but honestly I am quite happy with sort of the way it turned out. It's got perfectly round holes in it, it's got a keyhole in it, and it was all done within sort of 10-15 minutes. So I will see you in the next part. Thank you very much for watching, and I will be back with the handle. Hi, welcome back. So in this part I want to talk about the problems you're going to have with smooth and curved surfaces, face distribution, and how you cut those surfaces to avoid artifacts, stretching, pinching, this sort of thing. Now I modelled a screw head here, nice simple one, and you can see my edges are nice and clean. There's no artifacts on my model, we're not all pinched in at the corners, but if you take a look at the topology, you'll see that it looks rather weird. So normally I would just put an edge loop all the way around here to hold this edge, an edge loop all the way down here to hold this edge, and an edge loop all the way down here to hold this one. Instead, we've got something that looks like this. Now I'm going to use this sphere to demonstrate. So if I smooth it, it's perfectly smooth. Okay, if I start cutting edge loops in it, let's say I wanted to hold this edge, but I didn't want to hold the whole edge, just this part of it. So I go and I whack in a great big edge loop, one here to hold the edge, maybe one here and one here. And then I smooth. You can see that that doesn't look good at all. Now I see this all the time on people's models, and it's just not having an awareness of where to put your edges. So let's get rid of those edges I just did, and let's take a look at a fairly interesting phenomenon. If I take my multi-cut tool and just cut from here to here, now I'm going to create two triangles. I would quad this out, but for demonstration purposes it will become clear, and then I smooth. You will see I get no artifacts on the surface of this at all, really. Hence the strange arrangement we have here. Ours is quadded. Some of it might look like triangles, but it all has four sides. So let's build a screw head like this with, no artifacts, no pinching, no anything else, and see for ourselves. So I'm going to bring the grid back so I've got a point of orientation. Now you can start this from a sphere, or I'm going to use a platonic solid because we don't get to use them that much, and why not? Now I'm going to use a, let's see, quads obviously, an octahedron I think. There's something you don't see every day. Right, and I'm going to use two subdivisions, not enough, three subdivisions, there we go. And I'm going to cut this into quarters because I don't want to do more work than I have to do. By the way, this technique would work if you wanted to build a Phillips head, or a square head. I'm just going to do a flat head today. There really isn't much more work between one and the other. It's just in our reference, it's a flat head, so I'm going to keep it like that. Now, cut it into quarters. Again, you don't want to be doing more than you need to. Whoops, I missed one. Done. So now we need to cut the initial channel. So while in face mode, just select all those beasties, extrude them downwards, the gimbal in the center, and I'm just going to, whoops, get them flat. Actually, this is better if I just hit R to get them flat. There we go. And scale them until you can't scale them no more. I'm going to move this down here like so, and I'm going to get rid of all these faces that have been generated that we simply don't need. Done. I am going to kill this face, we don't need it. And now we need to weld these together. So we could move them closer together and do a mesh merge, that would also work. But this is fine too. Doink doink, done. Now that's not very straight. So face mode, select them all, convert the selection to a vertex, so control right mouse button to vertex, and there we go. Move it down a little bit, done, and done. Now just by the nature of this primitive we're using, this is also a bit wonky. I don't want it a bit wonky, so I'm going to change it. Now you can also select these vertex in the top view. That would be the smart thing to do. But there we go, done. So you can just scale this until you can't scale it anymore, and you are square. Now, we've got a triangle in here. A triangle, generally, it's not the end of the world, depending on where it is. It will stop Maya's multi-cut tool dead, so there's a good reason to get rid of it. It can also have some strange deforming effects, and if you're animating something using it for dynamics, you generally don't want it. But again, guys, it's not the end of the world. And end gone, that's the end of the world. Now I'm going to move this edge over here a little bit, and then I'm going to multi-cut an edge loop around here. Now I'm not going to worry about this for the minute. So this will act as a smoothing control edge. One of the many we will need to put in to hold the smooth. And now I can just cut from this vertex to this vertex. Now if I smooth at the minute, this is going to bow out. Now, to be honest, on a screw head from this far away, you're never going to notice it. So it doesn't really need that much more doing to it. However, as we are doing a tutorial here, I don't want to say the answer is to just do it badly. So let's put a smoothing control edge in here. Let's put a smoothing control edge in here. Let's put a smoothing control edge in here. And finally, let's put one in here. Now, this will hold the smooth. Perfect. So we're done. We can all go home. But alas not, because as I said in the start, now we've got all these edges really close together. Watch what happens. Oh, nasty. Just nasty, nasty, nasty. And the same down here. Very nasty. So we know we can't do that. That's not really an option for us. So what do? Let's get rid of some of these edges. So let's come in and get rid of the edges we just put in. So I'm going to delete edge. I'm going to come up over here. I'm going to get rid of these lot. Delete edge. We know we can't have them. These we can't have. Delete edge. These we can't have. Delete edge. And this one, I'm just going to hit delete. Done. So actually, let's delete edge properly. There we go. That's left us with a couple of triangles in the corner. This is not such an issue for us because we're going to actually use those triangles. Now, if you split a triangle along here, it's going to be a quad. One side, two sides, three sides, four sides. Let's split it across the face to create two more quads because we have 1, 2, 3, 4. So we're fully quadded, and we know this split across the face is not going to give us a huge artifact. We can quad up the other side by doing the same thing. Just like so. And now we're going to have to get a bit more inventive with the top here. So I'm going to come out, I am going to cut, let's see, from here to here, down to here. That's going to give me a quad here, 1, 2, 3, 4, and then I would really need to cut up from here to here, which is going to create a big triangle. But let's smooth it anyway and see how it looks. So I need to go into this view, and it looks good. There's no band across here. There's no big band down here. Slight pinch in the corner, but we'll sort that out. And that triangle's really not causing us any difficulty. Now, if you absolutely have to have it quadded, it's a pretty simple one. Stick an edge loop in here, and now you have 1 edge, 2 edge, 3 edge, 4 edge. Now you have a quad. Okay, so let's have a look what else would need doing to this. Basically nothing. That's it. Now all we need to do is mirror it. And now you can see the explanation for this weird edge flow here. It stops the banding around here and the banding down here. Now, unfortunately, there's no magic formula to this. I can't say always cut a triangle, bisect the triangle and go across the face. But if you do this a few times on a few objects, you'll definitely get somewhat of a feel for it. So let's mirror this, and the first mirror will be positive Z. So if we go up to our Dufry jobs here, that's not positive Z. Z, positive. There we go. Our merge threshold is once again way too high. Done. And then I shall need to merge that. Let's make sure nothing's been merged down here. I'm going to go 0.05. Okay. Now our next merge will be negative Z. So mirror, sorry, our next mirror, of course. Mirror Z negative, X negative, sorry, you can tell down here on the grid X, and it's going that way, so that would be X negative. And let's do a small merge of 0.05 once again. And we are done. So let's take a look at this in the old object mode. Now we've got a tiny bit of pinching in these corners, I can see it. But an easy way to remove this is just to use a smooth brush here. Now this is not necessary, I don't think you'd ever see that. Just pull it out a little bit, pull it out a little bit. Same on here, you could use the symmetry tools for this. A lot of things you could do. Gonna say that that's made it somewhat better. In fact, we're pretty good here. We've got kind of razor sharp edges. We're smooth. We don't have, like, this is all nice. So I'm going to come in, I'm going to scale it down because it's way too big to be the channel in a screw. And for the rest of it, I'm not actually going to model the screw head, the screw shank, sorry. I would just do it with a helix. So create polygon primitives helix, but we're never going to see it. So, you know, it's going to be embedded in a door. Now, let's take the edge and let's extrude downwards, put the gimbal in the middle, and let's extrude again, gimbal in the middle, and extrude again, gimbal in the middle. This time I'm going to hit Control and pull it this way. Okay, like so. And we could say from here we're done. We've got a big hole in our model, however. Not the end of the world in this case, but let's fix it just because we can. So you want to go to edge mode here and bridge. Okay, that's not going to do us a lot of good, is it? So we've got a huge n-gon right in the middle. Let's go across from here to here. Done. And across from here to here. Done. And now I'm just going to take in every second one. And that should give us quadded geometry. With a giant whacking great pole in the center, but in this case it doesn't matter. I am not animating this thing or doing anything clever with it, so giant poles like this are generally to be avoided, but it's all circumstance. You know, you'll see a lot of people in Maya say that you must do this and you must do that and you have to do this. To be honest, what you need to avoid are n-gons. You need to avoid hugely massive scene files, which you're going to then hand off to somebody who's going to get seriously annoyed with you. Other than that, there's not really a lot that you need to avoid. Let's go here, and we have any artifacts? Nope. We have nothing. Now, of course, if you wanted to extrude a shank for your screw, you could do that. You would just extrude this edge and then do the same as this at the bottom. So if I were to extrude this face, that would probably work. Control E, doink, and let's extrude the face. Done. So I will now put an edge loop around here, which I don't want to cut by hand, so I am going to bevel one in. Oh, that's annoying. It's at times like these you wish you'd picked something else to do for a living. There we go, and bevel that chamfer off. Done. So we are back to quads. We are, and what did I want to do with this? Select the edge loop. And oh yeah, I'm going to show you a new tool. Why not? Let's go to mesh tools, and we're going to use the offset edge loop tool. So I'm going to click here and drag here, and that will whack me in a smoothing control edge, two at once, 2 for 1, so to speak. There we go. Let's smooth this, and whoops. Okay, yeah, actually I think a screw does pop down a bit. You could put a smoothing control edge in along here if you wanted to. You just multi-cut here and here, but frankly I quite like that. All right, so happy accident. Bit of Bob Ross there. Now we've got our thing. Now one thing I would do is take this one edge right here, use the slide on edge tool, which we will find, where is it? Slide edge tool, there you go. I'm looking right at the thing, and just make these faces a bit more even. That will stop any artifacts that might pop up, even though I do not believe we have any. And there you go. Like I say, use a helix for the bottom if you want the screw thread. We're not going to need it, so I'm not going to put it there. But I hope there's been some explanation to you of why we have this, frankly, fairly convoluted and weird edge flow around the side here. It holds our smooth without, you know, putting giant great bands around our object. So that's it for this one. I'll see you in the next one. Thank you for watching, and I hope it was of some interest. Hi, welcome back. So in this part we're going to take a look at the creation of our door handle here. Now this is an interesting object because it seems to be somewhat hard surface on the handle itself. This is actually a 10-sided decagon. Then it goes more into a soft surface focus with this rounded cylinder at the end, and then finally we have a completely smooth cylinder at this end. So in this part we're going to discuss how you connect various different objects together and maintain the hardness in some and the smoothness in the other. Now this is a fully quadded object here. It doesn't have too much geometry on it, so we're not going to get any issues with banding or lines down it. It's all kept nice and clean, and in fact if we go into face mode here, whoops, let me just not select both objects there. So I'm going to go into face mode on this one object, so we can have a look at here. All and next, quads 404 faces, triangles none, n-gons none. So it's perfectly quadded geometry and it's a decent exercise. So let's make a start and create our own. So I'm going to go and open one of my library scenes here. Now let's just do a bit of scene cleanup here. So I'm going to hide all those and bring back my image plane. That was Control H and Shift H respectively. Not going to need this guy for a while, so let's get rid of him. Let's take a polycylinder, and I mentioned before it was 10-sided. It's actually 12-sided. So let's bring it up and get it in approximately the right place, scale it a little bit. I want it to be just as big as the handle is here. The background will be splayed out at a later date. So let's come in and give it 12 sides. Now the front of this is flat, the top is less so, but the front is most definitely flat. So let's start by grabbing the front verts here and just scaling them in so they are flat. That will give us a flat front. Now this sort of chamfer here is way too big, so I'm going to move these up a little bit and probably these down a little bit. Now I should have said, but you want to make sure you use a drag select because you want to select both the front and back vertex of this. So I'm going to drag select, and these ones would need to come outwards a little bit with the scale tool, so like so. Then just repeat the process for the bottom. So down a little bit with these ones. Now this doesn't have to be perfect. In fact, I don't want it perfect because this is a very old sort of rustic door handle, and it wouldn't be perfect. Alright, so that's done that. Let's take a look at it in the other view. And we're going to see that even though we've put these sort of chamfers in, we're still going to get a big issue when we scale, when we smooth. It's just going to go flat. It's going to go right into a round ball. So we need to stop this from happening. Now first I'm going to take off the end caps here. So I can go to cylinder end cap 0, and that way I don't have to delete a whole bunch of faces. I can simply delete these two and I am done. Now we need this thing to hold its shape. It's gone completely cylindrical and it's not what we need at all. So I'm going to grab the whole thing as an object. In fact, I'm going to grab it as edges. So I'm going to grab all the edges on this thing, like so, and I don't need this one, and I don't need this one, and then I am going to bevel it. So let's see, let's bring up the, whoops, that's not the right one. Let's go to the channel box, go into the bevel options, and you can either change them here or here. So the fraction of the bevel for me, I'm going to go down quite small, and I'm definitely going to turn off the chamfering. Now I need to get this back to object mode to have a look at it in the viewport. Let's turn off the wireframe unshaded, and that gives me that nice crisp edge. Let's smooth it. Still have a nice crisp edge. Now there is a possibility we'll get rid of some of these edges, might be a bit too crisp, but to start off with, that's looking pretty decent. So now we've got to bend it. So just scale it out until it's in a position where you think it would be for your door handle. Now you'll be able to change this later, so it's not mission critical. We then need to bend this. We need some geometry going down to bend it with. Now I've seen people bend in Maya before, and they use hundreds of edges, to try and get a smooth bend. It's really not necessary. Let's go to the mesh tools, insert edge loop tool. Now I'm going to need to bring up its tool window, and by default it looks like this. So I'm going to go to multiple edge loops, and I'm just going to do 5. That's all I'm going to need to bend this, and even that's probably too many. So let's come in, let's click, that'll put 5 equidistant end loops in, and as you can see, we are now looped up to bend. Now there's one thing I want to check. I want to check if these edges came in hard or smooth. So if we go up to display polygons and then soft hard edges, you can see which edges on this are hard and which are smooth. The dotted ones will be smooth, the edge ones will be hard. Now we want a hard edge here, and we want a hard edge. See, that's a bit weird. Okay, we want a hard edge here. Let's start selecting some edges. So this edge should be hard, this edge should be hard. That edge and that edge already are, that edge and that edge already are. So I don't know why the bevel didn't harden those edges, but it's not a problem. Mesh display, harden edge, and we are good. Now we've also got hard edges along here. It's not really going to make much difference at this part of the process, but let's make them smooth. So edges soften, so you want mesh display, soften edge. There we go. All right, now we can bend this guy. So I'm going to use a nonlinear bend deformer, nonlinear bend, and you can rotate this if it's coming in the wrong orientation. Ours luckily has not. Let's go to here. Now this will bend both sides at once. Okay, so as you can see, with just 5 edge loops, we've done an absolutely fine bend here. So let's come down and stick this one to 0, and now we have our 90-degree bend. So I can come in, I am going to turn this wireframe display off with the soft and hard edges because I don't need it at the moment. So polygons, standard edges, there we go. Going to flip into edge mode, select here, hit Control E, put the gimbal in the middle, and drag it out to where the end of the handle would be. Now I'm going to work on non-smooth view, so just hit 1. I'm going to have to put some edge loops in to try and mimic this shape. So let's go multi-cut. I'm definitely going to need to move it up about here. I'm going to need to splay it out about here, and I'm probably going to need one here. So vertex mode, let's get on with it. Let's make sure we're in the selection tool, move this up. And then I'm going to need to scale it. So let's see, what axis do we want to scale it in? We want it to get smaller along this axis, I should think. That is how we want it to get smaller, yeah. Yep. Yep. Okay, so let's just scale that up in this view. It's a bit easier to see. And I'll make that bigger for you guys following along at home. There we go. Near enough, I think. Now this, like everything else, can be a bit fiddly. And finally, I'm going to want to scale this down. I'm going to put another multi-cut in here just so I can move it a little bit. I think it's quite difficult to see where the background is, and then I'm going to have to scale that up to make that sort of nub at the end. And I am control scaling, by the way. Let's smooth and see what we got. All right, not bad, pretty close. This one needs a bit of tinkering, I think. And there we go. So that should do us. Let's hit object mode and take a look at this in the viewport. So you can see, even though I've got my object smooth, I've got those nice sharp edges there. I've got my nice bulge out on my handle. Now, a couple of things we need to do. We need to make sure that we have an edge loop along here. This one's too close, so let's just get rid of it. So delete edge, there we go, and then I am going to splay out the back of this. So this axis and this axis, it needs moving on. Make sure that I didn't muck up my scaling, I did not. So if it needs scaling on this axis and this axis, control and this axis, and let's go into the main viewport here. Okay, so something like this. Let's have a look at it in this one. Yep, and it actually goes cylindrical at the end. So let's talk about putting a cylinder on this. Let's go to unsmooth view. Let's select the number of edges we have around here, and we have 32 edges. Now that's a lot of edges. So to be honest, I am not sure that I need all of these middle edges. Let's get rid of them. The less edges you have, the better off you're going to be. So let's see if we can hold that nice crisp shape without so many edges. I think a lot of the time you run into problems because you just have too much topology on a model, and then it becomes extremely difficult to fix. So your mantra should always be simplify. If it doesn't need to be there, you don't need it. Okay, let's smooth and see how we're doing now. Perfect. So we just got a bunch of edges gone. Now let's check out once again how many edges we've got. Now we've got 22. So we knocked 10 edges off this, no problem at all, and it didn't affect what we look like, which is perfect. It's just what we need to see. So we've got 22 edges and we need this to go cylindrical. So let's bring in a cylinder and give it 22 divisions. Going to pop that up there, pop this up here. I'm going to turn the end caps off like so, and then I'm going to give it 22 edges, and I'm going to scale this up in the other view. So this one I want to scale up to kind of here. Okay, something like so. I don't need it quite so big. I think that needs to come down a little bit. Like so maybe, and side to side looks pretty good. So let's remove the faces. One here and one round the back, which I of course can't get to. Let's just isolate it. Okay, there we go, and unisolate that. Now I should be able to push this back a little bit, because I can always pull it nearer if I need to. And a lot of the time, if you've got like so, the bridging tool has a bit of a conniption. So let's combine these. In order to attach this to this, I would need these objects to be combined. So mesh combine. There we go. Actually worked today. One here and one here, and then modeling toolkit and bridge. Okay. So if we've done our job right, which I believe we have, when I smooth this, it should go from, let me bring the view up a bit bigger, having hard edges like so into completely soft edges. And we've got pretty good flow on this too. Now, if this was me, I would make this a little bigger, maybe, although on the reference it doesn't appear to be, so maybe I'll just leave it as so. But the exercise was basically to go from a hard edge looking object to a soft edge looking object, and I think we've pulled that off rather nicely. Now, we need to do a similar thing on the end, so we should have 22 edges still. We do. And as for edges at the top, we have 1, 2, 3, 4, 5, 6, 7, 8. That can't be 9, can it? Instead of my ridiculous counting, let's just go over here, double click here, and we have 9 edges. So we do have 9. Okay. So 9 and 9 being 18, I want an 18-sided cylinder. Let's just whop this into position, somewhat like so. So I want an 18-sided cylinder. Let's go 18. Okay, now I'm going to cut this in half, which is why I wanted it to be 18 sides. So interface mode, F11 on the keyboard for a bit more efficiency. Okay, now while that's come in, not an issue. So R and E and J to snap the rotation. Okay, like so. Join. And now we have 9 edges along here. 9 edges along here to join up with the 9 edges around here. Now we don't need the faces. We probably should have taken those off before we did this. Not the end of the world. So let's get rid of those faces. Let's make this a bit larger. Get rid of these ones. Done. So we have 9 edges on the top to connect 9 edges on the bottom, which is our here and here, and then we'll have some on the side. So let's just make this a bit smaller, get it approximately into position. So we want it like so. Somewhere around here. We can clean it up after we are done. Give it a little tilt. Now, how many do we need down here? So we counted, let's just do a quick recount. Measure twice, cut once, as they say. So over from here to here, was this our 9 edges, or was it from, it was from here to here, I believe. No, that's 7. So it was all the way around to here. Yep. Okay, so now we can count the edges we have left, and it's just 1 and 2, basically. So all I need to do is split this cylinder this way. Okay, done. And if I count the number of edges on this thing, it should be 22. And if I count the number of edges on this thing, it should be 22. Look at that, we did a thing. Okay, so again, combine this and this. So I am going to do a object mode and shift select and then a mesh and combine. Done. Then I can go ahead and select all these edges and bridge. Okay, and this is looking rather radically misplaced. But if I smooth it out, you'll see it does have a nice smooth end tip on it now. It's just not very well placed. So, not an issue, just Control Z until we are 2 separate objects. And that was completely my fault. I should have checked it out a bit more. Let's get it a bit like so. Let's check it from the front here. That's not very good either. And maybe it's a little bit too wide. So we'll do this. Okay, and now let's try that again. Oh, come on, Maya. There you go. You can do it. Yep, edge mode. And 1 and 2 and bridge. Okay. I do not like this artifacting we're getting here. I think it's just a case of this edge and this edge. Let's convert that to vertex. And let's move them out a little bit. There we go. So down a little bit. We're going to have to do a bit of manual editing here, folks, and not really a cause for concern. Okay. There we go. Let's smooth this out. And we're looking pretty smooth. So that gives us our end piece on here. Now, I'm not entirely happy with how that is pinched in a little bit there. So I'm going to go up to sculpting. I'm going to just grab the smooth brush here a second and see if I can just smooth the end out just a little bit. It's an old door handle, so kind of some wrinkles and mess on it isn't that bad. Let's smooth out the end here as well. Okay, not going to spend an awful lot of time on this. Just help that smooth along a little bit. Okay, there we go. So we have basically our door handle. That should slot into our model and become our door handle. Now, let's see. We can obviously put a back on this to make it a solid object. So because we can, let's do so. Control E to extrude. I'm going to put the gimbal in the center and I'm going to come in from here with the controlled extrusion like so. Take this off smooth mode. Okay, then I'm just going to bridge what's left of the hole like so, and then I just need to put in every second edge loop. Should be fine. So let's go 1, let's go 2. Wait a second, folks, that's not a good way to do it. 2 there. So let's see if we can start putting in every second loop here. So skip 1, skip 1. Oh, whoopsies. That's not a good thing. Delete edge. So we got 2, we got 2, we got 2. We can't have this one here, can we? Nope. I am an idiot. There we go. This one, skip 1. Okay, so I've put a few of these in the wrong place. Just gonna get rid of them. Okay, sorry about that, folks. Let's just go from here to here, done. Here to here, done. Here to here, done. And we're not having a good day today, are we? My apologies. I seem to have lost the ability to do simple counting. There we go. That's a bit better. And now we're all quadded up at the back. So if you want, you can stick a edge loop in here to stop it completely folding in on itself. And we are about done with this handle. One last thing I would do is I would move its pivot point. So if we come in and hit insert for the pivot point, I would then align it to this back vertex here. That'll do, close enough. The reason I do this is because I might want to do this in the future. So scale, E to rotate, and there you go. So I can now waggle the handle about. Okay, because it seems to be slightly elevated on my reference, but there we go. So that allows me to easily change the position of the handle. Let's bring in the back plane and see if we fit. We do not. So we seems like our hole on the back plane needs to be a bit bigger. Let's go into X-ray here. So I'm going to select all of the vertex necessary to make that happen, which would be all these. And then I am going to scale it. Am I actually in the right thing? Yeah, let me just reset the pivot here. There. And where do I want to scale it? I want to scale it this way and this way. So let's just make that a little larger. Okay. And let's go into 3. Let's go into object mode. And let's hide the handle from now. For now, sorry. And I want to select what? Let me just isolate this and turn off X-ray. I think something went a bit wrong there. No, it didn't. So I want to select all these faces here. So face mode. And extrude them. Somewhere around here. Now I'm going to multi-cut along here, and along here to stop this completely destroying itself. There we go, and 3, and that gives us the round circular shape for the handle to fit into. So let's bring the handle back, and there we go. Job, as they say, is a good one. So I hope that was of some interest to you, and I will see you in the next part. Hi, welcome back. So just between these parts, I've imported an image of our door handle from a different angle, and using the same techniques that we discussed in the first parts, I've actually arranged our geometry to appear over the handle. Now, if you look, you can see that we were pretty spot on. Now, this is useful for testing to make sure that your objects would fit in to a real-world scene if you're going to do some object replacement. It's also useful for that object replacement. If you need to replace something in a real-world scene with your CG object, you need to make sure that your object would be the same size and proportion to overlay. Now, in a later tutorial, I'm going to be discussing all this, but for right now, I thought you might just like to see that your modeling here that we did is pretty spot on to the real world object in question. Okay, so let's get on with modeling some doors. We're going to do some doors, some door frames, some strike plates, things like this. Now, I have a file called doors. There's nothing in it. Basically, it's just this image plane and our reference so we can have a look at what it is that we're trying to do. Now, there's a couple of tricks to modeling like this, and one of the big ones is extrusion order, which we'll go over in a second. Now, I'm going to start this door from a simple polygon plane. So, same as always, rotate it, make sure that it doesn't have too many subdivisions, because again, one of the reasons a lot of modeling goes wrong in my experience is because people are working with too much topology. Okay, I just scaled that back a bit, and I have X-ray on my shading. So let's just scale this up. Now, you'll notice I'm not building this to a real world dimension. That's because I intend to drop this probably in quite a few scenes, so the dimension that it needs to be will depend on the scene, and those dimensions can be quickly changed, which I'll show you how after we've got this modeled. So I'm going to come in and I'm going to multi-cut just along the line. So basically I'm just cutting an edge loop in here. There's nothing really fancy, and I'm actually going to cut out the middle panels. Now, in a real world door, these middle panels are actually recessed into the door, or at least the middle portion of them is. I assume that's done so they can save money by not having to build, completely solid wood doors, and it probably keeps the weight down a bit as well. So we don't need these faces. They're actually going to be holes. So get rid of them. Now we need to do an extrusion on our door. Now you always want to extrude forward. If we extrude forward, we get this. If we extrude backwards, we get this. Now if you have to extrude backwards, it's not the end of the world. All that will happen for you is that you'll need to flip the normals. So mesh display reverse is where you would find that. Now doors are actually wider on the back. So they can fit into the door frames, so they don't just swing right through. So let's do one extrusion, hit Control-E again, and do another extrusion. Now again, I'm not too fussy with the actual scale of this, because it will be scene dependent. So I'm selecting all these faces here, and selecting all these faces here. Now I shall do another extrusion, and flip the gimbal to the center, and just pull outwards. Okay, until we get the sort of lip you would have on a normal door. Okay, so that basically completes our door. Now we'll put some nice chamfered edges on everything when we're done, but I don't like to do that sort of thing until I'm in the final stage of the process, because again, it creates more topology and we may need to edit this. So let's just hide this guy. Let's call this door 1. And let's Control H and cut out some of these panels. Now these panels, you'll see, have a diagonal line coming in off them, which we can very easily mimic if we start from a cube. Now you'll need to start this from a cube as opposed to a plane, because you can't bevel a plane in the same way that you can bevel a cube. So let's get this roughly into position here. It doesn't need to be too spot on. There we go. Now we need to do a bevel on this, so just select the face and bevel it. Now that will come in with a chamfer that you don't want, but you can see the effect of that better on this view. So you definitely don't want that. Okay. Now you have one loop in here. We don't need to do any segments. We don't need to adjust the fraction. We can do all this very easily ourselves. So if we take a look at our reference actually has a raised portion in the middle, which is going to be this bit. So looking at the reference, it's quite difficult to see. We're just going to have to use a bit of common sense. And again, this is the sort of component that would be used over and over again. So I'm going to scale it out this way till it's about here. And do I want it a little bit thicker? Yeah, I think I do. So something like this. So that gives us the first of our edges and our component in the middle. Because of our topology, we'll be able to just cut here and cut here, and we're done. So that gives us all of the geometry we need to start extruding this thing. Now I don't need any of the back faces, don't need them, so I'm going to get rid of them. Okay, extrusion order. Now this one's important, and it's one that goes wrong for a lot of people a lot of the time. So if we wanted to, let's say, extrude this guy out, Control E, and just pull him out like so, I'm going to exaggerate this just so it's easier to see, and then I'm going to get this guy, and I think, okay, this guy needs to come further out, so I'm going to pull this guy further out like so. Okay, and that looks fine. You know, you look like you're on a winner. But if I isolate this face, you'll see it's massive. So we now have, let me just delete this and delete this. We now have a face over a face. See, if I delete this face, there's a face behind it. So you've got two faces basically occupying the same point in space. So when doing an extrusion like this, oh, I brought back the faces. It's better if you have two things next to each other to extrude them together to the level that you want the lower one out, the lesser extruded one, and then take the extruded one, the top one, sorry, whoops, and I've hit the wrong button, and extrude it out like so. Now, if we have a look here, if I remove this face, you'll see there's no face behind it. So extrusion order can get important. You might want to have a bit of an experiment yourself, just to see what makes a difference. Like here, we can extrude backwards without too many issues because there's nothing behind us. So that's going to come out just fine, you know. So that's recessed that a little bit. Now let's extrude this out a little bit. Actually, I don't want to extrude that because I don't need to. I can actually just move it out. Okay, so that gives us our frame. Now it's a little bit exaggerated just because I wanted you guys to be able to see. And we have a useless edge around here, I believe. So let's get rid of it. Delete edge, there we go. You always want to be removing anything that you don't need from a model. Extra edges and stuff will just lead to extra problems. Okay, so that looks pretty clean. So extrusion order can be quite important. Have an experiment, have a play around, make sure you're not creating those face upon faces, that non-manifold geometry. It's hideous to work with. If you pass it off to somebody else, they will throw a large conniption at you, I can assure you. Okay, so maybe this is a bit fat. This whole thing is a little bit exaggerated. So I'm going to center the pivot on this. So I've got a shelf one for that. There we go. And I'm just going to scale it back a little bit. Okay, now it was exaggerated, of course, just to make it easier to see on camera. Now let's take the whole edge around here and bevel it. So let's just use it here and give it some segments. Now I want this to be very rounded, whoops, very largely rounded like so. Okay, make sure that we are not creating any double edges anywhere. No, and I'm not going to smooth this thing. So, okay, and I just want to chamfer around this outside edge. Small chamfer, just so it helps catch the light when we render it. And this will make a huge difference. Now, once again, I haven't got a back face on that. Okay, that's perfect then, no problem. And what do we want to do in the center? Do we want to do a small chamfer around here? Small chamfer, you know, and as I was saying, these really will make a difference come render time. But you have to keep a permanent watch on your topology. You really do. It's so easy to do something like an incorrect extrusion and end up with, you know, a large mess. All right, but that looks like it's about fine for a door panel. So let's shove this panel into place with our main door. And we are not going to be building this thing 3 times, of course. We will just scale it. So, would I need to smooth that? No, in fact, smoothing that would probably be a detriment to me. Okay, nice and sharp corners, catches the light nicely. Let me just flick on the screen, not ambient occlusion, the anti-aliasing. And now we can get a better view of those nice edges catching the light. Should work fine. All right, let's bring the door back, Control H. Let's push in the door frame. And this is where you would need to size this up to make sure that it is right for your door. Now, don't scale this. If you scale it, you're going to push all of these out of whack. Like if I scale it like so, you can see this gets wider. These get wider, these stay the same, so don't scale. You want to grab the vertex, shove them in here a little bit, grab the vertex, and like so. This way we can actually change the size and scale of the entire door when it comes to putting it in another scene. So you can always edit the holes by grabbing the vertex on the hole. You should grab the whole row and, you know, making them bigger or smaller. So this way you've got sort of a very reusable door component. Now I want object mode, there we go, and I'm going to pull that until it's sitting quite nicely like so. Now I would attach this to the main door, but then again it makes it less reusable. If it's all, you know, merged together, it becomes a situation where you can't use it. So or you can't easily and practically scale it. This gives us some more flexibility, and to be honest, it doesn't need to be joined together. So again, you want the vertex here, vertex down, get it in line, and it should be in line lengthways. Done and done. So now we have 2 panels on our door. Let me just remove the grid, and we're looking pretty snazzy. Okay, let's get the 3rd panel. Now the 3rd panel I don't think should have a raised cutout in the middle because it's too small. So let's Control Duplicate, let's Control 1 and see if we can deal with that. So pretty simple. We're going to remove the faces from here, delete, and double click here, delete, and we are pretty much done. So I'm going to just go to Edge Mode and fill this hole up with the bridging command, and we are done here. Okay, so now I can use this for the middle piece. Now into the front view and vertex mode. Okay, like so and like so, and we're done. So we can not only, oops, okay, I'm going to have to shove these up and these up, just because they intersected a little bit. There we go. So not only do we have a door we could reuse now, we can also reuse these panels. These will make things like westcotting and all manner of other interesting bits and bobs. But there is our door. Now, we don't have a back on our door. Let me shove out the image plane. But that's fine. What we would do is mirror these components backwards, and our door itself does have a back. It's just these that don't, but I'll take care of that in a second. Now, I want to put a strike plate on this door, so that would be where the handle goes for things like the lock and, you know, the catch and whatnot. So let's quickly model a strike plate. So I'm going to bring in a different image plane here. I'm not going to need this one anymore. So let's pop down to the front view and import image plane. And I actually have an image here of a strike plate. There we go. So grab the whole door assembly and hide it. And I'm going to just do what I normally do, which is turn down the color gain so I can better see. Let's get this in the center. And we're going to need the screws we modeled in the previous part, but that's, you know, kind of the beauty of having some reusable components here. So we're going to need to shove this back there. Done. Now let's start again with the plane, and let's do the usual thing of flipping it around 90 degrees here. There we go, and removing its topology, removing its subdivisions. All right, now get it basically into shape. Now we're going to run into some issues here because we have circular holes and hard-edged holes at the same time. So we've got square holes and circular holes that both need cutting. Now, first things first, let's cut some edge loops in this sucker. So we're going to need one here and one here because we're going to need to extrude this outwards. And then we're going to need the edge loops to cut these square holes. But because we have round holes on this, we're also going to need the edge loops to hold those round holes in place. I'm also going to put an edge loop on the top and bottom here. Now I'm going to need edge loops on the side to hold the smoothing. Whoops. That one did not go up the side. Now we could have cut this model into quarters. Actually not quarters with this one. We could have cut it into halves. Now I'm not too worried about the location of my smoothing edge loops. What I do want to do is put a couple of 3 lines. Wherever I want to cut a hole, I want 1, 2, 3 edge loops. So I want one here, and then one down here. Now these ones are too near, so I'm going to just use the selection tool and edge mode to move these. Okay, like so. Now this is something we didn't discuss when we cut the hole before, but realistically speaking, you want some equidistant edge loops 1, 2 and 3. This will allow us to bridge outwards this way. Now, do we need any more edge loops on this thing? We do. We'll need to hold the smoothing along this hole, like so. And we'll need to hold the smoothing along this hole, but once again, I'm not going to create more geometry than I need. So I'm going to select this, and then I'm just going to scale them inwards, keeping everything symmetrical. There we go. And what else will I need? I will need 2. Let's go down. We'll need one along here to hold that smooth. We'll need one along here. You need them in the center line, of course, but I'm going to wait until I've cut the faces out for that. Okay, we'll need one here, will we? Let's see, that will be a hole. So, yep, we'll need one there. And same on the other side. We'll need one here at the bottom. Indeed, and here at the top. Now we're bound to have missed a few. Those inner ones will have to wait. But we've got the basics done. Okay, let's extrude this portion out. So edge mode and grab the edges we need. That should be all of them, I think. And then Control E to extrude and just pull out the extrusion. Now I'm going to hit R to scale, and I'm going to scale that in. Perfect. Okay, and now we will need a loop here to control this smooth, a loop here to control this smooth, a loop here to control this smooth. So when dealing with smooth geometry, you can see you end up with a lot of extra edge loops just to control that smoothing. The alternative would be to put in a very, very circular high poly hole, but then we'd end up having to cut everywhere. Now, let's take the faces out for a start, because I don't like having them. Done. Out we come. There's that hole and there's that hole. We can now insert the edge loops to hold the smoothing on the corners of the holes. Now I'm going pretty quick here, but the squarer and more even you get this, the better off you are going to be. So we need one here and one here. And one here and one here. Let's try smoothing this, and it stays pretty square. Now we are not square here in these corners. Can I live with that, I ask myself. Let's put a loop in here, and that's much better. Okay, so we've got our square holes. Let's just check it. Yeah. Oh, you'll see this one radically shifts inwards, and that's because we're missing one tiny edge loop right about here. So this can make a massive, massive difference here to holding your scale, and we should also have them in these corners also. You'll see that's much nicer. So we should have them here. Okay, so you're framing the whole thing. 1, 2, 3 boxes. 1, 2, 3, 1, 2, 3, here we go. And let's check this again. And much, much, much better. Now you're still going to get a little round artifact. There's not a lot you can do about that. You can try tightening up your edge loops a bit, being a bit more accurate than I was. But honestly, for this, it would be a little rounded anyway. That stuff is not milled to, sort of millimeter precision. Right, let's put the holes in. Now this one's going to be quite simple. Let's just put a multi-cut down the center of the line. Now this I should have done before. This should have been done at the start. It's not terribly important. I am going to now use these center vertex to cut these holes. Now this time we won't actually need a cylinder as a cutting guide, because I'm going to show you another trick. So we chamfer the vertex like we did before, then we select all 4 vertex, and then we circularize the vertex and add a division. And there you go. Now I can select these, scale them up to the place that they need to be in. Okay, that's kind of weird. What is that artifact on the front of my model here? Okay, it doesn't appear to be in this view. All right, well, we'll fix that. I think it's just a viewport error. I occasionally get this viewport tearing when I have the anti-aliasing turned on. So let's cut, and we'll check this model for n-gons and problems afterwards anyway. Let's cut. Oops. I made a right dog's ear of that one. There we go. Done. And done. And done. Now that should smooth into a hole. The reason it doesn't is because it's got a face on it. So let's remove the face. And now you should see it smooths into a perfect circular hole. So let's do the same with the others. So you can see we can cut square holes and round holes in the same model, without too much of an issue. Takes a bit of experience to get where you need to put your stuff, but the circularize vertex command is quite a good one for creating holes. One of the main reasons I did this in the full model rather than just doing it in halves, and I'm getting that issue again, but if I flip around here and have a look on this view, you can see I'm not getting it. So, and now it's gone. So yeah, it's an artifact to the anti-aliasing, I believe. Very annoying. Probably be fixed in one of the hot fixes, or possibly a graphics card driver update will do it. I am sure. Let's just do the last hole we've got here. Now we are of course going to reuse the screws that we made in the last part, because I'm not going to make new screws for this. Of course, that would be sort of defying the purpose of oops. So chamfer vertex, there we go. Okay. Why are you giving me grief, sir? Do I have two vertex here? I do not. Oh, but yeah, they are connected together. So making sure, I'm just going to come out of that. Click it. Okay, chamfer vertex. And it will not let me, for some reason, let me just try this one. Chamfer vertex, it won't let me change the divisions. Okay, that's very unusual. I'm going to do a edit mesh and merge just to see if I don't have any unmerged geometry. So that's merged up there, that's no good. That's a merge threshold that's too big. So let's try 0.5. Okay, and that hasn't merged anything. That's merged me down into a triangle there. Okay. So it could have been that I had a stuck vertex. Let's go to vertex face and see if I can see anything unusual. I cannot. Okay, let's try this again then. These problems crop up. It's, you know, it's just things that need to be dealt with. Chamfer vertex. No, let me try the chamfer vertex options box. Settings, remove face after chamfer. That shouldn't do it. Okay, for some reason it is just not happy. But not to worry, we can, of course, just do this the old-fashioned way. Okay, so an impromptu second demonstration of using a cylinder as a measure. So let's bring a cylinder in here, and that's a bit big. So normally I would, in all honesty, debug this problem, of course, before continuing, but I don't want to do it on camera right now. I will do it in between the parts. So I'm going to just make this one unselectable. So let's go to the modeling toolkit and object freeze. And that way I can grab my vertices behind and just do this. So both at the same time. Same time, there we go. So this is the same way we did it last time without the circularized vertex and add divisions, because for some reason my chamfer vertex command is playing up on me. There we go, that's a hole, that's a hole, that's a hole. That one looks like a star, there must be a face on it. There it is. And we are keeping our smooth, we've got circular holes, and we are all good. Now, before we continue and give ourselves a big congratulatory pat on the back, let's hide that image plane. Okay, and it doesn't appear to have... probably hide the right one would help. And I need to unfreeze this cylinder and get rid of it. Okay, so round holes, square holes, same model, smoothed, and everything is kept fine. We have our strike plate. So let's go to face mode, click it all, extrude, and let's put the gimbal in the middle and just give it a bit of thickness. That's a bit much. So let's give it a bit of thickness this way. And these things are extremely skinny, so we don't want it too thick. There, something like this. We can always change the thickness later on. Now, this hole will just shrink, so we're going to have to put an edge loop around here. Now, technically speaking, we should put 2 in. On something this thin, I might just put 1, to be honest. It keeps the geometry down, and it shouldn't make too much of a difference because it is very thin, but let's do it properly anyway. Okay, now let's go like so, and our holes should remain nice and solid, which they do. Now, we're also going to need to do that to the outside of the model as well. When you add thickness, you have to control the smoothing around the outside and the inside, as well as on the face. Okay, let's have a look at this. And now for the big test, do we have any nasty geometry? So I'm going to go up to the constraint again, and I'm going to hit F10 to go into F11, sorry, to go into face mode and quads. Let's have a look. N-sided. Okay, all and next, there we go. N-sided, none. Why is that? Oh, it hasn't. It was just my mouse cursor. Quads, okay. Triangles, none. N-sided, none. Quads, all. So we should have pretty consistent topology, geometry. So I'm quite happy with that. I'm going to set this to nothing, close and reset. F8. Now, we need to fit this guy to our actual door, and here's where scale once again becomes important. So I'm going to bring back the door model here, and I'm going to move this. Actually, I'll move the strike plate. Now, we need to get this into size for the door. Now, if we just do it by eye, let's say we were to just size this down and shove it in the door somewhere like here. Now, that looks about right to me. I would say that that is about right. But before I go and commit and cut a bunch of holes in this door, I'm going to bring the handle into the scene. And I'm going to get a measurement for a normal door, get a measurement for normal strike plate and a normal handle. That way I won't be out of scale. Because part of creating these reusable components is just to bring them into the scene and drop them in. I don't want to have to, you know, go, oh, okay, is my strike plate too big? Is my handle too big? Etc, etc. So I'm going to run off and get those measurements, and I'll see you in the next part when we'll get this measured up and we will cut more holes in the door here. So thank you very much for watching, and I hope to see you in the next part. Hi, welcome back. So I want to talk about scale and why it's such an important thing. Now, everything we see here is proportionally scaled to itself. So this door frame is in the right proportion. It's just the wrong real world scale. It's about 6 centimeters high at the moment, which, you know, is not really a door you would want in your house. The same thing goes for this door handle. It's proportionally scaled to itself. We know it's correct. We've matched it not only against the reference, but we've actually matched it against a real-world photographic shot, and it fits perfectly. However, the same can't be said for the two objects when we bring them together. Now, this door handle is obviously massive, and really quite funny. I'm thinking of building some very large door handles, but yeah, anyway, if I scale this down, a lot of people have done this. I've seen it in many shots, and that looks about right. Maybe a bit small, so then maybe I would scale it a bit bigger, and yep, Bob's your uncle. We are done. Now, when I render this, it only looks right because we're in this very isolated view. We've got nothing for a semblance of scale other than the door. There's no banana, there's no nothing. So what can happen is you can model your objects like this, you can combine them together thinking that you're done, and you'll render the scene and it just won't work. Something in it will niggle at you. There'll be something in the back of your mind, but you'll never be able to tell what it is. I was talking to a friend several months ago who was working on a large production, and they brought in a digital double that was 5 centimeters out of scale, which doesn't sound a lot, but it had a knock-on effect for the animators, had a knock-on effect for the guys doing the cloth and the fluids, and it ended up costing an awful lot of money for the production house. So you're not just scaling stuff to get your own work to look better, you're scaling it so your colleagues don't strangle you to death in your sleep because you'll cause them so much extra work with your inattention to detail. Now, a couple of bits on that inattention to detail. This is a strike plate. It's designed to go on a door frame, so we'll have to edit it slightly. Now, we do need a strike plate for a door frame, so luckily enough for us, we needed this. We just need to chop off this bit. Also, with my door and my lacking attention to detail, we need to put a lip across the top, and the lip itself at the moment is too thin. So if I were to select the faces along here, just so we can create a thinner lip, and the faces along here, now we may have a problem with bisectional faces. With this sort of, whoops, we may also have a problem that I can't select things in Maya, apparently, after 20 years of using it. Right, there we go. So I'm going to convert this to a vertex selection before I move it. And I think we're going to run into an issue up here. Look, when I move this back, you see it tears? That's because there's another set of vertex underneath in exactly the same position as these vertex, because when we extruded this, we extruded it in the wrong order. So let's go to Edit, Mesh, and Merge. Let's use a very small merge threshold. And now if I come in and look at this vertex, it should be all merged. Now, merging to a very small threshold is fairly common practice to fix those common errors that come up. Faces in the same place, vertex in the same place, etc., etc. Now, all the way down to here. And let's just move backwards because I want this a little bit thinner. It shouldn't be quite so fat. There we go. You know what? I'm going to convert this to a vertex selection like I should have done in the first place. And then I can also grab this vertex, and there should be a couple of those on the bottom, and then I can keep it all the same. So backwards we go. Be sure to pay attention to where your lines are going and where your vertex are going and whatnot. And there we are, done. Now let's grab some faces here and extrude upwards. Now this might cause us an issue. It shouldn't really, but it might. So let's check the vertex. Let's grab a vertex here, and is it all together? It is all together. Are we all together there, sir? Yeah, we are. We're gone out the back of the model there, which is why that looks funky. Okay, so yep, we should be together. Good. As I said, that shouldn't have caused us any problems, and indeed it didn't. Okay, let's get everything to scale, and I'm going to start by taking a look at my grid. We'll fix that strike plate at the end of the tutorial and turn it into something for the door lock instead of the door frame. Okay, let's look at my grid. At the moment it's in 1 centimeter increments. 1 centimeter increments is neither used for ornament when I'm trying to scale in the hundreds of centimeters. So let's go to display grid. Now you can use the measuring tools for this as well, and we'll do that to double check, but for a ballpark this is no good. Let's put it on 1 meter. So 1 meter every will be a grid line, and then 5 subdivisions will make 20 centimeters. Let's change the color of the actual grid lines so you can see what I'm talking about. And the subdivision lines are in gray, so that's 20 centimeters, 40, so on and so forth, 1 meter and 2 meters. So now I've got a grid that's actually of some use. I'm going to come in, I'm going to select the door group, I'm going to move it up, I'm going to F to focus in on it. I want to make sure it's on the floor. This is another common mistake. People scale stuff and don't check that it's on the floor. So of course, it's right height ways, but 20 centimeters off the floor, and then you send that off down to your friend who's supposed to be splashing water on it, and nothing works, and no after work drink for you that day. Okay, so I'm going to hit move the pivot down to the bottom, just so when I scale upwards. So then I can zoom out on the grid here and scale this door to about 220, which is what its real world counterpart is at. Okay, now I'm just going to take the other objects which I have measured. Now I'm going to reset the pivot here just to make sure its rotation is correct, and my door handle is about 24 centimeters high. At the moment it's a door handle for ants, So I'm going to say that would be about 24 centimeters. Now, if I want to be precise, I can create a measuring tool to measure it. So distance from the top, distance from the bottom, and 23.5. So again, if I wanted to be precise, I could come up a little bit and go like so. Now I've got my door handle in approximately the right place, although embedded in the door. There we go. Now I need to know how far up your average door handle is off the floor. So mine was 90 centimeters, which I don't know, I would say was around there. Let's see how accurate I was. So this is the 1 meter mark. So I am not accurate. So that would be, actually, where would 90 centimeters be? That is the 1 meter mark, yeah. So the bottom of the door handle should be around in the middle of this grid mark, which would put my door handle right in between these 2 wood panels, which seems perfect. I mean, that seems like exactly where you'd want to put it. So it appears people who make doors don't just make the dimensions up as they go along. So that looks to be where my handle would be. Now I think my handle should be probably a bit close to the edge. Now I need to put my strike plate in, and that will be determined by the size of the handle to a certain extent. Now I modeled a generic strike plate, which I'm going to size up to, you know, approximately the same size as the handle, just so we're not dealing with vastly different scales. Okay, that seems a bit small. So it seems like it would go somewhere around here in the door. Okay, and possibly a bit bigger. So we are going to measure that. We're actually going to get it to the right scale. So I'm going to say that it would sit in like this. Now I've looked at my strike plate. The handle is just above where the actual door latch thingy comes out. And it looks like the lock comes out here, so I'm going to move this down a little bit, and please excuse the noise outside my office there. I'm going to just select the vertex and grab all of these. In fact, I'll grab all of them and shove it down a bit. Now this was a generic locking plate, it wasn't actually made for this door, so a bit of alteration will be necessary. So there we go, and there we go, and it looks like to be a goodly size on the door. Okay, now it's got one problem. This, as I said, would be for a door frame. Now it looks pretty much identical to the one that goes on the door, except the door frame one has this and the door one doesn't. So basically this would be put on a door frame and then beaten around to stop the whatever you call that handle bolt thing that comes out. My mind has gone completely blank. Anyway, to stop that thing bashing your door in. But in our case, we don't need it. So I'm going to make a duplicate object to this, because I probably will use the same one, because the holes should be in the same place for both the door and the door strike plate. And then I'm just going to cut this guy off here. So actually face mode is much better for this. So let's just cut this chap off. And now we've modeled the locking plate and the strike plate. So, you know, we can just pretend like we planned that, because it worked out rather nicely. So I'm selecting the edges on either side because I don't want a giant great hole in this thing. And I'm going to bridge across, and there we go, like a brand new one. Oops, what? Aha! Because I bridged across, I didn't actually get the lines here and here. This is why, even if you're not intending to smooth a model, it's sometimes beneficial to actually smooth it, simply because smoothing will show you a variety of errors. So let's go into vertex mode. These vertex will not be merged. Okay, that actually did merge them. That's a shocking surprise. Normally the multi-cut tool is a bit more useless than that. But it does appear like it got it absolutely right. So let's smooth. And no artifacting. Yeah, it looks like we are good. And I think that'll do it. Really, I don't need to be too accurate on this. I'm not trying to replicate a particular door. Alright, so little fixing required there. Let's move this thing into position. Now, on my door, this where the latch comes out is just above the handle. And this is in line with the keyhole. So, again, because we just made a generic latch, these are little tweaks that need to be done. In fact, in this case, we can take them all. There we go. So let's get that in line with the keyhole. There we go. And now we need to cut the holes in the doors. Now, I'm not in the door. Sorry, so I'm just going to take this and isolate it so I get rid of everything else. And I'm going to put it around here. That seems to be fair enough. Now, I'm not going to cut the holes for the screws. That would be a bit of a bridge too far because they're going to have screws in them. So let's use our multi-cut on the door itself. Now let's go to object mode to select it, and we want to cut around this guy. Okay, I'm going to leave a little bit of a gap so you can see that we've gone to the effort of cutting it out. Okay, down to here and cut. Now we'll need some cut lines to cut out this and this, and then we will of course need one here and one here. We will need one here and one here to cut this out. And again, I'm not going to cut out the holes because they will have the screw holes because they will have screws in them. Now I am going to select the face on this and extrude it backwards, but I want to make sure I am not intersecting any other geometries. So I'm going to focus on that face, go into the actual model and have a look around, and no, I am not messing with any other geometry, so that's fine. I can just extrude that backwards with no penalty basically. And I can do the same here. In fact, before I extrude these backwards, because we've got an extrusion order issue here, I am going to lock this model. So this door frame, I want to see through it and I don't want to select it. So I'm going to go to Object, Freeze, then Shading, X-Ray, and now I should be able to select all of the faces that I need to extrude backwards. Here we go. So it's all of these. I can still use this model as a guide. I just don't have the option of accidentally selecting it. Now I can see through the model. I can also see that I'm not going to interfere with anything if I extrude backwards here. So let's put this in the center and extrude backwards. Basically, I want to extrude backwards the thickness of the strike plate. Okay. Now I need to get the bigger holes. So this one. Okay, that one's not sized correctly. So I'll just take this one for now and extrude it inwards. Wait. Okay, that's better. Extrude it inwards like so. Just gives me a nice hole. And this one, I need to move this edge and this edge outwards. So we go into edge mode, of course, this edge and this edge. I think that's correct edges. It can be difficult to see on X-ray. Also, I need this one and this one. Okay, yeah. Like I say, it can be difficult to see on X-ray and get the right selection. But there we have it, and I need to move outwards like so. And now I should be able to select this face and Control E and extrude backwards. And I'm not interfering with anything in there, so that's fine. Okay, let's come out of X-ray and see what we got. Let's unlock our strike plate. Okay, and if I pull the strike plate away, you should now see the corresponding holes for it, and indeed we do. So can I recess the strike plate successfully into the door? Or not the strike plate, sorry, the locking plate. And yep, and I've even recessed it a little bit too much, like I'm not very good at this, because it kind of looks cool for the render. So that is that in there. Now I would need some screws, which if I unisolate my view, I can simply pinch from my door handle. Now if everything is in scale, with all things being equal, I need to reset that pivot. These screws should be the right size. Okay, no, my pivot is fine. I need to reset the rotation on this object. There we go. And now I can rotate it. Now, they might be a little bit off. They might have used M3 screws for this and M5 for this, but I would imagine that these should be approximately the right size. And it looks like the screws used for this plate here are bigger, but only ever so slightly. So that makes me very, very, very happy. That just means that the screws used for this locking plate would probably be bigger because they're more substantial, because they're holding the lock on, not just, you know, the decorative handle piece to the door. Let's make sure they're all the same size. They are. Okay, there we go. So just duplicate these screws and up we pop. Done. I'm going to give them a bit of leeway. It'll help see on the render. And done. Okay, so that's looking pretty good. Now we do have a few bits left of tidy up to do. We need some interior bits and bobs for around there. But overall, we're looking pretty good. You know, very high detailed. If we wanted to do sort of a photorealistic render now, we've got the level of detail we need to sort of achieve this. Now, I'll be back in the subsequent parts, and we'll finish off sort of a door frame. We'll talk about double doors and stuff like that as well. All right, so thank you very much for watching. I'll see you in the next part. Hi, welcome back. So in between the parts I went ahead and modelled a door frame that you can see here. Now this looks simple enough, but it will highlight one of the big problems with Maya's bevel tool for us. If we go underneath, you can see the topology on the bottom. Might look a little strange, but it's all quadded, and the reason for this is that bevel. So if I go ahead and push that one I made earlier back there, I'll just run you through the process of making another one and show you some of the pitfalls of Maya's bevel tool. So I'm going to start with a simple box here. I'm just going to scale it roughly to the size of the door frame. Okay, so somewhere around here, or the hole in the wall, should I say. Now, I also made a quick wall, but that's nothing but a cylinder with a hole cut out into it to the same 12 centimeter dimensions we built our internal wall, which I think are pretty standard for internal walls. Now, let's move this guy out so we can see. In fact, let's leave him where he is and isolate him in the viewport. Now, a couple of things first. I want to remove some faces from the middle, like so. And I want to expand this out. Now I went ahead and measured my own door frame, and it is 14 centimeters around this way. So I'm going to make this one the same. You can obviously find more exact reference online, but for demonstration purposes, this is going to work just fine. I am now going to cut the door in half, and I'm going to cut it into approximately a quarter. This is because I only want to model 1/4 of it. Of course, I see no need in modeling more than I have to, especially as it's going to cause problems later on. So that's the back off. Let's take this off, make sure we get this face down here, and we can start with what appears on the surface of it to be a relatively simple exercise. So first things first, let's put in the gap that the door would actually fit into, and then there's a couple of decorative sort of twists up here, so let's go ahead and do that. Now I need to do my extrusion. Now, bearing in mind the extrusion order, This is going to stay where it is, and this is going to stay where it is. Now you'll notice I didn't double click. If you do, you'll select these faces down here, and you most definitely don't want that. So let's extrude this out to a distance of about 1 centimeter. And then let's extrude this one again to a distance of 1 centimeter. Okay, now I'm going to try and bevel some of this stuff, and you're going to see some of the things that go horrendously wrong. Now, it's also created for me some rather unsightly faces around there. Don't need those. Okay, so bevel should be fairly simple. Now the trick is with a bevel, if you can select the whole loop, like if I select here, it selects the loop around here and it goes down here, and you should see when I get to the bottom of the door, it hasn't continued to select it here. This is going to be a problem bevel. Not every time, but most of the time. So watch what happens. I hit bevel, and it does indeed bevel it, or chamfer it in this case, and now I've got an end gone. 1, 2, 3, 4, 5. So this wouldn't fly. I can't leave this. If it was a small triangle, I might get away with it, but it's a whacking great end-on, and I'm not going to get away with it. It's going to cause problems for all my colleagues down the road, and cause problems for me as well when I come to, use this in different scenes and whatnot. So what we could do is split the face from here to here, but that would leave me a nasty, unsightly face and turn this long face into an end-on. So let's undo that bevel. And before we do the bevel, let's put some edge loops in. Now, these are going to look like edge loops for controlling a smooth, but what I'm trying to do is get a square on the edge that I want to bevel. So this edge I'd want to bevel, so it's going to need a square. So I'm going to cut down here and here, and that would be a square. So I'm going to bevel this edge, I'm going to bevel this edge, I am probably going to bevel this edge down to there, and I'm going to bevel this edge down to there. Now they all have a square. Now the reason for this will become apparent in a second. The reason, by the way, that this one doesn't have a square is because I intend to round this one over, and that's going to be even more complicated. So I am going to select the edges I want to bevel. Now remember to double click, because you want definitely to have those selected all the way around. Okay, and I think that was the 4 that I decided to bevel. Now if you wanted to bevel more, you could come in and put more geometry down, but this 4 will be fine for me. So I'm going to bevel them all at once. Bevel, you'll see they're nicely chamfered. I'm going to add a segment to the bevel, so I get an extra edge, and that's it. I'm going to make this a lot smaller than it is right now, like so. That's down to you and your personal preference, but this will be fine for my illustrative purposes. I am going to select a bunch of vertex on the bottom of this door. So F9 for vertex mode and F to focus. Just that allows me to easily manipulate the camera. Now I'm going to come in, I'm going to multi-cut from here to here. Done. That, believe it or not, is not a triangle. It's 1, 2, 3, 4. So that's cleaned up that bevel. Let's clean up this bevel. And done. And then I have the other 2 that need cleaning up. So 1, and there was 1 over here, I believe. And 2. Okay, that is now all quadded, and we have our bevels in play where we wanted them. In fact, if we go over to our shelf and use the constraint here and make sure we are in face mode and then select all and next, if I select n-sided, you'll see there isn't any. Quads, all of them. Triangles, none. So that's the thing with the bevel tool. If you can select a whole edge loop, here I'll demonstrate. If I can select a whole continuous edge loop, generally speaking, I'm going to be fine. So I can select this whole continuous edge loop. It goes all the way around the model. Let me just focus in on it. So it goes all the way from corner to corner. I'll be able to bevel this. It won't give me any problems at all. But this will lead me neatly on to being able to talk about hard and soft edges. Now we did this slightly with the door handle, but I'll show you again. So let's just close and reset all of that. So let's bevel this guy. Now again, I'm going to do 2 segments and a really small fraction on this. So something like 0.01. Okay, and as you can see, this has presented us with no n-gons, no geometry problems at all. Okay, and it's still a little big for my intent and purposes, so 0.5, there we go. That's probably big enough. Let's go and turn off the view here, and that's looking pretty good. But I can see a certain artifact here. Now, if we go to display polygons, where are we? Soft hard edges, there we are. You can see that I might have some in the wrong place where I don't actually want them. So, do I want this to be a hard edge? I do. I kind of don't want this to be a hard edge though. So if you find these edges, you can come up, select them, and go to Mesh Display, Soften Edge, and you'll see those go dotted. Okay, now if I come back to object mode and look at this, it looks slightly better to my eyes. Now, probably there's a hard edge around here that's not really necessary, but I'll leave you to play with where you want your soft and hard edges. For me, this is not a big deal. This looks about right. That bevel is probably just still a little too fat, so I can come in here and turn this down to 0.2 probably. I just want a tiny bevel there. Okay, so again, if you can select the whole loop, do so. You might have some issues though with where it decides to put your soft and hard edges, depending on how you do your bevel. Okay, and our topology down the bottom is good. Now let's tackle something ever so slightly more complicated. Let's tackle making a large rounded corner. So I'm going to select the edge here. I'm going to double click it. I want to make sure that I have all of it before I do this. I do. And then I'm going to bevel. I'm just going to keep the view down here so you can see what happens to the geometry down here. So hit bevel, give it a large offset. Now for some reason that's not letting me bevel as much as I would like, the fraction I mean. Let me just undo that. Yeah, okay. It's because this bevel is running through here now. So I should have waited to do this bevel. That's not a problem. I'm just going to undo it for now. It was more a demonstration of the creation of soft and hard edges and whatnot. So let's just take that one out. You can put it back in later. But again, order of operations, do these bevels first. All right, so let's hit bevel. And I'm going to add 6 segments. And I'm going to go to a fraction of 1. And then if we look down the bottom, sorry, this is a little awkward, you'll see here our topology is very broken. Okay, I'm also going to make sure that I don't have vertex in the same place. I do, because I used a very large fraction. I have verts in the same place. So I'm going to come up and do a mesh merge on this. I'm just going to make sure that we don't lose this very small detailing here. So edit mesh and merge, and we've lost it all. So 0.01. And that seems to have kept that small detailing. Now I do want to check this to make sure we don't have any bad geometry. So I am going to go to my constraint, or next I'm going to go into face mode and quads 80 n-sided 1. Okay, that's the one we expected because that's the one down here. I'm going to check for triangles too. None. Okay, so that's kind of what we expected. You know, we knew this was going to happen. So let's constrain to nothing, close and reset. Now, grab some verts down here and just hit F to focus the camera so you can see what you're doing. I'm going to need to cut some edge loops to join these up too. So let's put, I don't know, 1, 2, 3 over here and 1, 2, 3 over here, and let's do some joining up. So let's grab this one to this one, this one to this one. Now you can take some more time and align these a little better. It really doesn't matter that much in this circumstance. Let me just come over and grab it to this one. Now we've got a big triangle here, but we will deal with that shortly. Okay, let's deal with the triangle. Now this is a good example of when I generally leave a triangle alone. This guy's not really doing anyone any harm. He's not going to deform. So, you know, your choice. If you can fix it, you probably should, just for the sake of neatness. But a triangle there would have made relatively little difference. Depending on if you have a brief, maybe you're working with a brief that you must be fully quadded for the dynamics later on down the line, then by all means fix it like I just did. So this is now a quad, this is a quad, this is a quad. We can double check. I recommend you double check all the time, so you're not all the way through the process. N-sided, quads, all of them, n-sided, none, triangles, none. Okay, so that has fixed up our geometry there a treat. Okay, now I will demonstrate again how easy it is to bevel something if it's just, you know, a single contiguous edge loop that you can meet from start to finish. So let's select these edges around here. Now these are going to require multiple selections, but I should have no problem beveling this because this edge loop is going to meet. Now this is not 100% gospel. You can always run into problems with a bevel tool. But you can bet your life if you end on a corner, you are going to run into problems. Have I selected that and that? Yes, I have. Did I select anything else up here? Probably the top edge. Yeah. Okay, that just went through all manner of selection, didn't it? Okay. Let me just select this again. Okay, now I've selected the continuous edge loop here. Let's do a bevel. Okay, and as you can see, that's given us no issues. Now let's do another segment even. Still giving us no issues. Make it a bit bigger. Shouldn't make any difference to us, and indeed it does not. So I would generally bevel the bottom of a door like this, especially if it's sitting on a hardwood floor. It'll give you that illusion that it's slightly off the floor. Now, don't take my word for the fact that that just worked out the box. Let's have a look, shall we? So let's bung it onto face mode and quads. And n-sided, none. Triangles, none. So let's constrain nothing, close and reset. Okay, so that's basically it for our door frame. A very simple thing, but also a very nice object to demonstrate the bevel tool and some of the problems you might run in. Now we would need to mirror this geometry, of course, on looks like positive X. So I'm going to go to Mesh, Mirror, and I'm going to set it to X positive, and yeah, that'll do. Oops, I want that on bounded box, and I want this absurd merge distance all the way down here somewhere. Done. And now we can mirror it across the other way as well. Whoops. Okay, so you see here I've got a split in the top but not in the bottom. I can tell you exactly why that happened. If I select these vertex and scale them together, they weren't straight. Now they are. So just do that again, mesh, mirror, done, and put it on bounded box. Set the merge distance to something a tad more sensible, and we are good. Let's just, if you want to make sure that they've actually merged together, you can grab one and pull it about, and yep, that's merged. Okay, let's mirror it across, looks like -Z. So I'm going to go to mesh and mirror. And Z negative and bounded box and cut the absurd merge distance again. Done and done. There's our door frame. So I hope that's illustrated some of the problems you're bound to run into using Maya's bevel tool. And if you've had problems in the past, I hope that's maybe helped you. Now, also in these parts, I modeled some hinges, if we can get a look at those. Now, they're just barrel hinges. What I've done is I've used a cylinder and the same number of sided sphere, and just connected them together and merged like we did with the end of the door handle. I've then just extruded one of these to a thickness to give me a hinge. So I'm not going to cover that. There was nothing particularly complicated about it, and it isn't something, it's something we've done before. So thank you very much for watching this part. I hope that might have cleared up any issues you were having with the bevel tool. It's a big one. I've seen lots of people have a lot of issues with it. Just mind your topology. So I'll be back in the next part. Hi, welcome back. So something that I always put in scenes, or nearly always, is power outlets, light switches, plugs, cablings and things like that. So I want to take it over, or go over it with you now. I'm also going to show you a quick way to do cables. But let's model this relatively simple plug socket. So I brought in some image planes, just front, back and side. I shall leave them in the project folder. And all we need to do is we're going to model a quarter of this. We're not going to muck around doing the whole thing, of course, because that would be a waste of our time. So let's go for one subdivision. I am going to grab some vertex over here and shove it back. It's probably the lowest point. Same here, lowest point. Is this in the center? It's not, is it? But it doesn't actually matter because I'm only going to model half of it anyway. There we go. What am I thinking? And I'm going to pull this back to here, let's say. Now, thinking about it, let's go like this. Let's get rid of some faces. So let's multi-cut along here, where this point would be, along here, and along here, and along here. Now, these vertex look way too far forward. Like so. We're going to need something there probably, but I'll sort that out in a second. I'm going to select the edge here and just click Shift with the Move tool activated, so W, and pull this out to extrude it. Like so. Now let's have a look, see how are we going to do this. Okay, let's just pull some verts. Now I'm just going to shape this a little bit. I'm not going to go too extreme here. So like so. In fact, it would be better, wouldn't it, if we put one here as well about. Now the lines on this drawing are extremely thick, so it gets a bit difficult to see. Now I don't really like this arrangement so much, but when we smooth it out, we'll be able to move a point, so that should be fine. Okay, let's select some faces. In fact, let's select all the faces and move down to the side view. Now I'm going to hit the Control E to extrude. In fact, don't need to. Hit W to move and then Shift and extrude up to the lowest point. Then I'm going to select some top faces. So these guys that need to come out, 1 and 2, and these guys that need to come out. And actually I'm going to do this extrusion one at a time. So Control E, now we're in a 3-dimensional object, and 1, 2 and 3, Control E, and up we go. So this is looking a little bit thick and a little bit in the wrong place. So I'm just going to move it like so, and I'm going to scale it down like so. What about this? Yep, this is also looking a bit thick. Now we've got some faces on here that we genuinely don't need, and we'd also need to pull this point up to here and this one up to here. Now let's look on the top view. So it seems like we need that one a bit further down there. Let's just straighten those up. There we go. So let's have a look. Can we multi-cut across here? Yeah, we could, but okay, I'm going to let the smoothing do that. As you can see, the ones on the top have already started to smooth out in the shape, so I'm not going to do the work I don't have to. Now, I do need to get rid of some faces here, so I need to get rid of all of these faces on this way, like so, and all of these underneath faces. Oops. So I accidentally double-clicked there and selected every face on the model, which is not at all what I wanted. Did I get the back? Nope. Okay, now we can mirror this thing across. Oops, missed one. Okay, let's just have a look at how this is going to smooth out first. So first things first, if we look on the front view and flick that to X-ray, you'll see we need a bit more of an indentation here. So if we look at the way our model is based, why are we not getting it? Okay, let's smooth that out. And probably just going to grab a couple of vertex here and move them in. Okay, that's going to give me a more rounded over appearance to my edge there without me having to do a lot, which is my favorite thing. Let's mirror this guy before we start putting smoothing edges in. I forgot a face. There we go. I'm obviously having one of those days. So this is looking okay-ish. Really don't like this edge here. So I'm just going to grab this vertex and move it more central, like so, before I start mirroring it around. Anything else I don't like? Nope. Happy. Okay, so we're going to mirror this in positive X and negative Y. So, mesh, mirror, and a ridiculously large merge threshold. There we go. And are we good? We are good. Let's mirror in Y. So bounded, and we want to mirror in Y, and we want negative, and again, I don't need a merge threshold that big. There we go. So that's basically it. Some smoothing control edges will go in, which we shall put in now. So first things first, we need to stop the back flying out like that. So let's get a multi-cut around the back there. Now we need to stop these flying out as well. So let's do that. That's looking a lot better already. Now we've got a similar problem here. So one here and one here should ease that situation. Now, I think I'm looking at an actual picture of an American plug. You'll have to excuse me here. Might come as a surprise to some of you, but I am not actually American, as you can probably hear. And let's smooth that, and that looks better. But on the picture I'm looking at, these are far more inwards. So let's come out. Let's take away any extraneous geometry, and I'm going to do a vertex selection. Just grab these four here, and then I'm going to scale them inwards, and these two, and I'm going to scale them inwards a little bit, and I'm also going to scale them this way a little bit. Then mine was slightly circular on the outer edges, so I'm going to put a multi-cut somewhere in the middle. Now I would have to do this on the bottom as well, so I'm going to end up chopping this in half. I'm going to chop the bottom off. It's really just there for me to check the smoothing at the moment. So that's looking pretty good. Now I'm going to select this vertex and just scale them out ever so slightly, and I'm going to hit 3. And yeah, my image I'm looking at looks a bit more like that. Just a little bit out, maybe. There we go. Now we can put some control edges in. So one there, one there. Got one there and one there. Let's have a look at that. Yeah, that looks a bit more like it. So it seems to be less tall on my reference image, but you know, I'm going to say that's pretty good. These things come in a lot of shapes and sizes, and I just want a simple one here anyway. Now, if I look at the reference, the other thing we've got to deal with is, yeah, this tapers down quite significantly, which we are missing at the moment. So let's just bring that in like so. And how about the end? The end is not quite so rounded, so let's put one of those in there, and it holds its shape. Let's check it out. Looks pretty good. Some more detail could be put in this, but on the whole, I'm pretty happy. So I'm going to go ahead and chop it in half again and mirror it. So we are the same top and bottom. Now you'll often find or see people put the model together just to smooth it, to see what it looks like. The model sometimes has to be whole for you to get a good look at what it looks like, but we can now just do this. Mesh mirror and make sure we are on -y. And with not such a large, ginormous merge threshold, of course. There we go. And this will basically act as our plug socket. Now, let's put a hole in the back. Actually, before I do that, I completely forgot the sort of serrations on this thing. So this should be simple enough. Let's use this view, and it will just be a case of 1 and 1 and 1 and 1. I'm trying to keep these even as possible. I mean, if I was being really pedantic, I would actually measure it out. Don't think it's necessary for this. There's so many different designs of plugs like this that, you know, it really doesn't matter. They all have slightly different size cuts and whatnot on them. So let's extrude inwards. And I am going to use Control and this guy and extrude us inwards a little bit. There we go, something like that, I feel. Okay, so I think that should do it. You might want to put some smoothing control edges in here to just hold that smooth a little bit. In fact, I think I will actually do that. Let's go for it. So, gonna need them all around these chaps here. Probably one. No, I think we'll get away with that. Let's see. And let's check that. Yep, that's better. Now, I could put them around the inside too, but I don't think that's necessary in this case. I kind of like the way that's smoothing out. So if I've missed some, you know, huge features of an American plug here, I do apologize. But as I said, I'm not that familiar with them, only from holiday and whatnot. Okay, let's put a big hole in the bottom of this thing. Now, this should be easy peasy for you guys. Just select here, and I'm going to just chamfer this vertex. Okay, so that gives me 4. Then I'm going to select all 4 and circularize the vertex. Would you stop? Ah, there we go. Tool went a bit bonkers there for some reason. Let's add some divisions. Here we go. Okay, and ooh, I would have really liked a cut around there. Where is that cut going to go? Is that going to destroy anything essential? No. So I am going to put a cut around here and a cut around here, like so. And then I'm just going to have to finish that off by hand because we now have n-gons here. So everything stopped working. And there we go, that should do it. I should be able to cut again along the bottom. I can. So now I am just going to multi-cut from here to here. Done. From here to here. Done. From here to here. Done. And from here to here. Nope. Selected the wrong thing. It's just not having it today. There we go. Done. Now you could cut another loop around here to reinforce this hole a bit, but in this case I don't think it's going to be necessary. Doesn't need to be that good. So I'm going to select the edge and then I'm going to slide on edge. Let's try a slide on edge. Okay, no, that's just going to turn me back into a square. So I will actually scale along both of these axes at once. There we go. Get room enough in there for the cable. Okay, so really just one thing left to do now, and that would be to add the front of this guy. All the decorative bits I would put on with a texture, you know, the writing and the safety standard and whatnot. But let's make some prongs. Okay, so these are going to be exceptionally easy. Now you could cut a square hole in this for the prongs to go into. I don't think you're ever going to see it, so I'm not going to bother. But if you do want to, go ahead. The more accuracy and realism you get into a thing, the better it's going to look. I mean, it is really that simple. So I'm going to say my prongs are like this, doinky doinkies. Let's go this way. Now, from what I understand, these have points. So I'm going to multi-cut down the middle and then take this vertex and this vertex and shove them backwards until we're all pointy. So something like this, I think it would look like. So I'm going to Control D and move this. Now this is probably too pointy, so if you smoothed it, that's going to happen. Now that's an issue. So let's multi-cut. In fact, yeah, we'll do one and then we'll just copy it over. Like so, and I'm going to need one that goes around here to stop this completely annihilating itself. And then one round here to hold the shape, and that should be less pointy and more rounded. And indeed it is. Now, they also have a hole in them, from what I can see, on both here and the reference. So let's whack an edge loop in here. Let's whack one in here and one in here and make a hole. Now, we'll also put one round here to help us get that vertex to make our hole. Now, this is nothing new. Again, we just did this, so really I'll do it on camera here because it's a bit of a quick process. Now, we'll do one side and we'll mirror. So let's see, yeah, here I go. So chamfer vertex, 1, 2, 3, 4, circularized vertex, add a division, well, if nothing else, after watching this, I hope you'll have learnt a lot, but if nothing else, really we've done enough holes now that it should be really simple for everybody concerned. It's one of those things that's a little difficult the first time you do it, but yeah, after that it becomes quite easy. So let's come in here and make the hole a bit bigger. Let's use some reference. So I am going to, there we go. Okay, I'm going to say it's about that big. That's kind of what it looks like on my picture here. So now I have a hole. Let's just check that remains a hole. It does. And we need one on the other side. So the easiest way to do that is to chop the model in half. And then just mirror it. So we have the same hole on the other side. Now this should be in, should that be in plus x? No, where should it be? Negative x. There we go, an absurdly large merge. Done, and we should have a hole going through it. Now that hole should probably be connected to itself here. So let's just bridge across. And there we are. Now that's probably now going to need some of these guys to hold it in place. It does. Let's see if that looks like the end of an American plug. And in my limited experience, that looks like the end of an American plug. So get rid of this one and Control D and move this one into position. And there we have our plug socket. Now I'm going to call this one apart. That was a nice, simple enough thing to model. In fact, if you ask me, I'd say the door frame was more difficult, which seems counterintuitive because it seems like, something as complicated as this would be much more difficult than a simple door frame. But to my mind, the door frame has some trickier elements to it. Now I'm just going to, before I sign off, push this in a little bit and then go along here, multi-cut on, done, and I can go around as well to help hold that. Now I should close this off. This should be closed. So a couple of ways to do this. Simplest way would just be to bridge it closed, but that won't give me the faces I need. So bridge it shut, Control 1 to isolate just this so I can get a better look at it. And let's cut it. So easy way. 1, 2, straight up here. Done. Cut it across the middle so there's a cross in the center, and then you are basically quadded. Okay, 1, 2, 3, 4. So that should do it. Now you want to put a multi-cut around here somewhere. Let me just, yeah, stupid tool. Let me go to object mode a second and multi-cut. Okay, there you go. So it's because I have things that are hidden. So 1 there should do it. And right enough. Control 1 to unisolate selected. And now we've got a hole we can shove a cable in. Okay, so there it is. Now, before I go, I'm just going to do a mesh combine because I'm done with this thing now. Done. And then it all either smooths or unsmooths together. And we have a plug socket. So when I come back, when I come back, we'll model the plug socket and I'll show you a quick way to do wire that basically goes anywhere you want it and can go across anything. All right, thank you so much for watching. See you in the next part. Hi, so this will be a nice quick one. I opened up my scene file here today to find that Maya had completely decimated some of my objects. Now, here's 2 faces it managed to save. And don't get me wrong, I am overjoyed to have these 2 faces back, but I'm pretty sure I modeled more than that. Now, it happens when you have history on an object generally and you save the file without clearing the history. Now, I would recommend that you clear your history, of course, but sometimes it's just not feasible. Sometimes you need to come back and work on the object and you need that history there. And let's face it, Maya shouldn't be doing this. So what can we do to solve it? Now, you'll either get a partial object left, you'll get no object at all left, or you might even end up with an object that looks completely corrupted. Well, before you throw the rattle out the pram and go screaming down the street, you can try this. Go up to Window, Node Editor, graph your object, like so. You can see mine has quite a bit of history on it. And we can then start to remove some of this history. So like I said, polymirror is often a culprit. So if I just pull these down here so we can see them, I'm going to unattach the whole node chain from the polymirror. And then I'm going to grab the shape and I'm going to unattach it from this. So I've lost a mirror, a tweak, and a bevel. Then I'm going to come in here, I'm going to take the output and I'm going to plug it in to the in mesh of the frame shape, and my frame is back. Now, of course, I'd need to mirror this across again and do whatever I needed to do with it, but there it is, it's back. Now, before I do any of that, I'll probably delete the history off this before Maya decides to eat it again. So edit, delete by type history. But in my defense, 2020 is also doing this now. So here is another frame that I built to a slightly different specification, and it's got 2 polymirror objects on it. So I'll just remove the history. Nope, no I won't. And that's not the hotbox just playing up. I cannot get rid of it. So once again, back to the node editor, graph it, and you'll see here they're just hanging around, flapping in the breeze. I can disconnect them. It has no effect whatsoever on my object here, and then I can just get rid of them. Okay, so definitely some bugbears in 2020. If you open it up and your file has been completely corrupted, your object's gone for a Burton, try taking some of the history off it in the node editor. It might just work for you and it might save you some time. All right, that's all I've got for today. Thanks. Hi, let's jump in and model this rather surprised looking American plug socket. Now I picked this one because it's not symmetrical top and bottom, so we can't simply mirror it. We'll have to do a copy and merge, which is something we haven't done much of so far. So I figured this would also make a great asset for our library, but also allow me to demonstrate how to deal with something like this. Now I'm going to get this roughly into place. I'm starting with a polygon plane. which, as you've seen by now, is a fairly normal starting point. Now I'm going to come in, I'm going to just snap these verts to grid. I'm just going to hold X here and snap it to the center, and hold X and snap it like so. And then on the top and bottom, obviously, I'm just going to take a best guess. Now, those have gone slightly out of alignment, but again, that's not really something you need to worry about. Let's make sure these ones are in perfect alignment too. Done. Okay, so that gives us our starting point for our model. Now, when I've got circular holes and square holes to cut out, I'll often cut the square ones first because they generate, generally speaking, the easiest but most amount of edge loops. So let's come in and start by first cutting the hole. Now, we know we want this thing to stay square, which means it's going to need a whole bunch of edge loops around it. So realistically speaking, you're going to need, I've put those in entirely the wrong place. Right, let me start this again. So one here, you're going to need one on the up and down, of course. Try and get them equidistant, and then you're going to need one here and one here. You're also going to need one that cuts across here like so, and one that cuts across here like so. Now remove the center faces. Like so, and you should end up with 3 boxes around. We have 1, 2, we do not have a third. So multi-cut. And this arrangement should hold your edge quite nicely. That should be fine. Let's check it. Yep, that's going to hold my edge quite nicely. Okay, now we have to cut out the circular hole down here. So let's start with an edge loop in the center to give ourselves some vertex to chamfer to. Let's put one here and one here. That will give ourselves something to tie to. And let's select vertex and chamfer. Oops, I am on the multi-cut tool. Never a good thing. There we go. Chamfer that vert. Come in, multi-cut around 50%. And just start moving your vertex around. So I'm going to put the top and bottom ones up here. Now I'm going to turn my grid off for a second. There we go, to get rid of that yellow line. There we go. Now one's going to have to go here, obviously, and one here. So this is slightly different than the normal circle arrangement we would build. One around here. Now we're going to have to hold this corner like so, and we're probably going to need a reinforcing edge around here too. Let's smooth that, see how it does. It's not bad. It's definitely within a tolerance for this kind of thing. Let's maybe move these down a bit, get more of the shapes that we need. Okay, we can play with that a little bit later. This won't smooth across because it's on a plane. We'd need to give it some depth, which we'll be doing in a little minute. So let's go to object mode and mirror this in positive X. So mesh, mirror, positive X. The merge threshold is too high. Done like so. And we should, when we are smooth, get a pretty decent view. Now, I noticed that this guy is a little bit smaller. I don't know if that's a feature of American plug sockets. I assume that it is. So let's make him a little bit smaller. Okay, so, and this way too. I am guessing that's so you can't get your plugs in the wrong way round or some such. And there we go. Let's have a look at this in this view. Let's smooth him. And he looks pretty good. Okay, now we'll need to copy him down to the bottom. And I want to do this before I extrude any depth. So I'm going to delete the history on this object for a start. So edit, delete by type. History, done. Duplicate the object, move it down like so. Okay, and you'll notice that we are Not quite a perfect match. So we have 1, 1, 1, 1, 1. We are missing 1 here. This one will go to that one, and so we're missing 2. So we're going to need to create some geometry for that before we do anything else. So from here, ooh, I don't want to run it all the way down the bottom. That will interfere with my loop here. So what's the best way to do this? Let's cut here. Now we're going to need another one over here, approximately there. So that will cut that. Let me take it off smooth view, and I should be able to just slide in here. Yeah, I could, but better would be to create an edge loop a bit closer, so I'm not creating a big split across a large face. Now this one is probably small enough for me to get away with not doing this, but for the sake of neatness. Now I notice those vertex seem to be unmerged, so I want to check that before I go any further. No, they seem to be fine. Okay, just a trick of the light then, I guess. So it's multi-cut from here to here. Done, and that should give us all quads, I believe. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now we need to merge these two objects together. Have I just seen something else here? Okay, so we're going to need to do some work on this. This edge, for instance, needs to be over here. Now, is it more beneficial to move this one? This is smoothed, so that would not be good for picking out your edges. So 1, 2, 3, 1, 2, 3. We've got this one here. We've got this one here. So this edge or this vertex doesn't really matter. It's going to come in this way a little bit. This one's going to come in this way a little bit. And all these look pretty close together. So let's merge these objects together. Just combine them, sorry. So we're going to do a mesh combine. And then I'm going to select all the vertex along here. Let me zoom out a little bit. And just do a mesh. Edit mesh, sorry. Merge. Okay, and that should have merged all of those. Seems to have done. Let's do some checking. Yeah, we look fine. And we are merged. Now, we do have one small problem. Our bottom is not in the right place. But that's kind of okay. I'm going to just select the verts here and move them all down. Okay, and now this doesn't line up, but again, not really a huge issue. Okay, and now we should have our fairly completed socket. So let's smooth it, make sure it smooths out all right. Looking pretty good to me. Now we need to give it some depth. So select the entire edge around, and you can just hit shift and extrude it backwards a bit. There we go. Let's check the corners on the reference. Now we should be pretty good to the corners. Let me unisolate this. And whoops, put it into object mode. So we would want this like here. Okay, so this is too fat. Let's make it a bit thinner. Like so. You know what? Let's undo that extrusion altogether, because I just realized something. I'm also going to need to obviously extrude all these holes, and I'd rather do this all in one go. So just hold shift and go backwards just a little bit. Okay, now I want an edge loop around here to hold that smooth a little bit. Okay, and I'm also going to need to do the same in here. Now, if I look at my reference, these American plug sockets seem to have a little bit of a chamfered edge on them. So let's achieve that. Let's go here. Now, what would be the best way to do this? I'm going to select some faces, I think. So all the faces around here and all the faces around here. And then I'm just going to scale them a little bit, I think should work. So we're going to come in this way. In fact, which axes do we want to scale on? All of them, I think. Maybe not. Maybe just backwards a little bit, and then down a little bit, and this way a little bit. Now, let's smooth that and see what we get. Okay, kind of not what I was hoping for, really. So, let me come up with a different way of doing this. Let me just check the reference once more. So I'm actually going to hide the object while I just get a good look at the reference. So what are we dealing with here? Okay, I see. It's like, yep, it's a pinched extrusion. All right. So what's the best way to achieve that? The best way to achieve that is probably to get rid of these, my apologies, and select this edge. And let's go. Let's click scale, and this way and this way. So hold shift. Okay, hold shift and control. No, that won't let me do it, will it? Okay. No, that's not what I'm looking for. Okay, that'll do it. So, shift and extrude from the center. Okay, then we end up with this. Then just move the whole thing backwards. And that should give us that pinched extrusion we are looking for. So, apologies for the time taken there. I had not realized it was like this on the reference, but that does us quite nicely. So let's do that again, just so you can see it again, because I had a bit of a senior moment there while I was working out the best way to do this. So edge and R and control, shift, actually just shift will do it. And let's move that in and then shove it backwards. Okay, like so. Put an edge loop around. Done. And that gives us that nice detailing that we had previously missed, which I believe is how an American outlet looks. So we need to do the two on the bottom. Let's go ahead and sort that out while we're here. My apologies for this. I kind of missed this step. I am not that familiar with American sockets. Now, if you want to get the back all equidistant to each other, which I kind of do, let's go into the side mode here and select all the vertex along the back. So let's go into X-ray so I can see through this. Okay, yeah. So that's actually going to be a bit tricky because we didn't come out far enough. So I'm going to select the edges on these guys and just extrude them out a little bit because I need a bit more depth. Okay, like so. And you can go as far as you want because we're going to even them up now anyway. Okay, now I can select all the back vertex and even them all out. Just like that. Okay, let's smooth and make sure we're on a winner. We seem to be. Alright, that looks like a pretty solid plug socket to me. Let's just double check it on the reference. And that looks fine. Now, we need to build the back of this thing, which should be fairly simple. Let's just start with a polygon plane again. So, J, flip it around. Scale it up till it's about the right size. Quite difficult to see on this reference. Okay, I'm just going to grab the verts and shove them up to here. In fact, let's go to the inner limit of the switch. Or socket in this case, should I say. Okay, let's select the edge. All the way around, and let's extrude from the center again. So somewhere around there's done our top and bottom. So that's a bit annoying that I need to readjust this, but there we go. Something like that would seem to be in order here. Now I need to cut a hole for this chappy. Right, and that hole will need a smoothing edge. So let's put one here and one here. And do the same in all four corners. Now we could have, of course, done only half or quarter of this. In fact, yeah, let me do that. Yeah, no, actually this is so simple to do that it's not really a problem. I'm going to put one in here for the screw and one in here for the screw. Okay, one splitting us right down the middle. Done. That gives me a vertex here and a vertex here. So let's cut out some faces a second. Done, and let's smooth and see if our edges meet up with our edges, because we don't want anything else. Yep, that's why, if you're wondering, I didn't put so many smoothing control edges in here as I did to hold these, is because I wanted it to round out. So we'll have a tinker with that in a second. Now this line, for my mind, this one and this one is... yeah, how are we going to do this plug socket? Let's just give it a try. So I want to put a multi-cut in here and do the same on the bottom. Again, could have done a quarter of this or a half of it. Probably would have been ever so slightly faster, but this is one of those tasks that's going to be, you know, so quick anyway. Let's see. We want to chamfer the vertex. Okay, and then I want to circularize it. And add a division. All right, so do I really want to cut across all that way? No, I really don't. Okay, let's have a look here. Let's grab this guy, and this one grabs this one. Whoops. Need to press return to finish the tool. Okay, now I just need to do a bit of scaling. So let us grab all of the verts and scale it a bit. And that should about do it. Let's check that that is indeed circular. It is. And now we need to do the same down here. So I'm just going to pause for that because I think you've seen me do this enough. Okay, so that's got our holes cut in this. Now all I'm going to do is grab its edge. If you see me use this menu, by the way, as opposed to the hotkeys, it's because my microphone is sitting right in the way of my keyboard, so it kind of makes it difficult at times for me to actually hit the hotkeys. I wouldn't recommend that you use the same technique. It is always pretty much faster to use the hotkeys. So let's extrude the holes back, because we're going to need some decent holes. There we go. Multi-cut 1 and multi-cut 2. Done, done, done. So let's see. Let's compare us to our reference. Right, what don't I like? This needs to be extruded backwards. Like so. And then it will need most certainly a multi-cut along here to give it a nice sharper edge. And now we're not actually matched up that well with our socket here, especially in the corners, and this is really something I would expect. So let's come back here and try and get ourselves a bit better. Now the way we'll do this is by grabbing these edges here and moving them around. So you'll see this going to affect how my corner smooths. So make sure you're not going to affect anything else. And try and get yourself a corner that looks like the one that you want. Now you may also need to shove some vertex about to exactly match the case you're going for. Like all these, for instance. Let me lower all these together because they're all too high. Okay. And I can also drag these in parallel. So what we're looking to match here is this. Because although it doesn't flawlessly match our reference, we want our two things to match up. There we go. So that kind of matches nicely. Now these ones need to get a little more on the ball. And this is just different smoothing on different objects is always going to cause you some issues like this. Now let's see. So these I think are going to need to come in. Yeah, pretty much. And then we're going to have the same issue down here. It's too far away. You want to get as nice a fit as you can. It's just going to look better if it's much more neatly fit. So same along here. Let's more neatly fit it. And I'm doing this in a bit of a rush, but you might take a bit more time with it. So let's have a look at this in this view and see if this is fitted any better. Okay, that's fitting in kind of nicely now. Now I do want some more shape here, I think. So let's see that. That's a bit better. And possibly even some shape around here, although that's going to cause me some other issues. So let's see, am I happy? Smooth here, and make sure we're smoothed here. I'm pretty happy with the fit. I'm pretty happy with all the holes. And sorry about the jump on the video there. Maya decided to have a bit of a conniption with me, but we're back where we were. Now, I think I just said I was happy with the holes and the fit, and indeed I am. The one thing I'm not completely happy about So let's just shove this guy back in here because I had him out. The one thing I'm not completely happy about is how crisp these edges are around here. So let's do something about that before we go any further. Now I'm going to take this edge, I'm going to delete the edge. I am going to flip down to my modeling toolkit. I'm going to select this whole edge across here, and I'm not real happy. It matches the reference, but it doesn't make me happy how near this hole is to the top. So this is an occasion where I am going to just change it just ever so slightly and bring it down. I'm going to do the same on the bottom. I'm sure there are many designs of these. Oh, do we have an unconnected? No, we don't. Just couldn't see it. And I'm just going to make that a little bit further away from the edge. Okay, because it was annoying me personally. Okay, let's get away from my idiosyncrasies for a minute and bevel the edge of this instead. So it's going to be a full closed loop. So as we discussed before, the bevel tool should work just fine. It's probably going to leave us with some triangles at the corner. I'm also going to bevel here, 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 and here to give us that nice look I'm going for. I'm going to make sure I've got the whole lot, and I am going to bevel, triangle in the corner. So give it another segment, and now we've got quads in the corner. Okay, so I'm going to go to object mode, and there you go. That's given me a much nicer, sharper edge that I'm looking for. So that just makes me a little bit more happy. Now I could also do that to the outside of these holes because it will be one contiguous edge loop. So let's go to bevel and use a very small fraction, and there we go. So let's check that out, and that holds the whole shape a bit better than this one down here, which is all soft and squishy. Okay, so let's do this one down here too. These are small tweaks. You probably get away without doing them. You know, I like to build my stuff a little bit over-engineered, I guess you could say. But that is, in my opinion, better than the alternative. Nobody ever came running out the office at me and said, hey, David, this is way too good. So that's not really a problem that you normally have to put up with. Now, the reverse, I would say, is this matching the reference? Let me just check before I edit it, because it seems like this would be a little more curved. And it seems I am right. So what else can we do? We can bevel around this guy just to give it a bit more of a stronger edge, although this one's probably not necessary. But, you know, little fractional bevel here, never hurt anyone. There we go. So we'd have to do the same here. Always worth taking some time for little finish up details. Done, 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 and done. Now, if you wanted to give this thing a little thickness, now for me that's not really important because it's going to be behind a wall, so to speak. So let me just see something here a second. I seem to, oh no, okay, that's fine. That's just an intersection with the front plate, which is absolutely fine. I want that sticking out a little bit. I'm just checking the angles here. Everything looks good. I mean, these things are mass-produced plastic. They're not supposed to, you know, they're not supposed to be within 0 point something microns. You know, you want this gap in between here. It'll help sell your realism quite a bit. Okay, so that's looking good to me. Holes are looking good. Everything is looking pretty good. Now, I don't have any aliasing turned on my viewport, which is why you're seeing jagged edges. But I'm not concerned about those. Those won't appear at render time. So we're good. So I'll be back. I'm going to connect the plug to this thing, and we'll be off to the races. Hi, we've got our plug and our socket in the scene here. So the way I'm going to scale these things up is, we know this is proportional to itself and this is proportional to itself. Let's get it to a real world scale now. So I'm going to move these in here, and these should obviously fit in the socket. They don't. So I'm going to scale up the whole group here uniformly, and I've got them grouped. Just Control G if you select some objects together. I've probably mentioned that before. And do we fit in the socket? We seem to fit in the socket pretty well. Now I'm going to group the plug and the socket together, Control G, and then I'm going to scale the whole thing up. So this is equidistant to 70 millimeters, which is the size of a US plug socket, apparently. So let's come in here. We'll use our grid. I'm going to isolate this lot on the grid. I'm going to move it to the bottom here, like so, and I'm going to throw the pivot point, let's see, down here probably. Now one of the ways we can check that we are accurate as well is the forks on a plug should be around 18 millimeters. So that should allow me to check. So if I scale this up to 70 millimeters and the forks on my plug are around 18 millimeters, then everything is in scale. Now I did not do a very good job of getting that on the floor. I might also go up and change my grid to display, let's say 10 centimeters instead. Might be a bit easier to help me get it scaled. So let's just scale this thing. Let's change the pivot, as I said. Insert, just align the pivot down here. It doesn't really matter where. I'm just going to close that. So this should be 20 centimeters, 40 centimeters, 60 centimeters, and somewhere about halfway through here should do us for about 70. So let's create a measuring tool, distance tool, and one here and one here, and that is 68.1. So you know what, 68.1 isn't that bad. Let's just give it a tiny tinkle here, and that should be around 70. Okay, now we have the pleasure of measuring our plug socket here, and let's just reset the pivot. Done. And we're going to measure our plug socket, and we're going to see if this, let's isolate it, is around 18 millimeters. If it is, then we've done our job very well indeed. So create measure tool. In fact, I think they're allowed to be from sort of 18 millimeters to 24. Not that I'm hedging my bets or anything. Let's have a look. 17.1. So maybe we are a tad off with the scale of the plug, because that would be, let's see, but you know, we're minusculely off. That would be 17.9. That would be 18. So let's select the whole plug and scale it up just ever so fractionally, like so. And that would make us perfect. Let's bring the socket back, make sure we still fit in the socket. And look at that. Perfect. So my initial scaling was probably just a little out, but that's a plug that fits perfectly in the plug socket. So we know our scaling was probably pretty decent. Okay, so that's the plug in the socket. Now I did check how far a normal US outlet is above the ground, and it's between 30 and 40 centimeters. So let's move this thing above the ground here. So that should be 10, 20, 30, 40 something. So if I put a floor plane in, because now that will be easier, if I get rid of all of our measuring tools, get rid of them all. And I'm going to put the floor plane in. I still seem to have one here. It's a locator. Just get rid of it. And that's my original reference, just hide it. Now I'm going to put a floor plane in, and let's say you wanted to create a cable for this guy and you want it to hang along the floor and go this way. So I'm really just going to touch the surface of what's possible here, but I thought it might be interesting for you to see how this is done. So I will have a tutorial that comes out that covers, in a little while, that covers dynamics like Bifrost and things like this. What we're doing right now. But first, let's just get a curve on the grid here. And you want to make a nice long bit of cable. Because we can. There you go. So we got a nice bit of flex with a bit of wiggle room to it. Now, let's move our nice bit of flex here into the center of our... Where is the... Okay, we're still on snap to curves. Or for some reason we are on snap to curves. I'm going to modify and center the pivot, which I can do here. And I'm just going to get that in the center of my object there. Okay, so that'll be central enough for demonstrative purposes. Now we need to make this thing dynamic. So let's come in, let's select it, let's go to N-hair and make selective curves dynamic. Now this is probably going to fail and be all rigid because we don't have enough CV points along our original curve. So before we do that, let's put some CV points along our original curve. So let's go to, let's see, surfaces or curves even, because we want to rebuild a curve. And let's give it 100. Rebuild. Now I'm going to check the control vertex on that, and there they are. So that should be enough for this particular simulation. Now I am going to go back to N-hair, make selective curves dynamic, and that should just drop down without too much of an issue. Now you'll see here that it's a little bit stiff still, you know, but that's fine for our purposes. We're doing cable, we're not doing something more flexible. It's also attached at both ends. So let's select the hair system. Let's go into the follicles. Let's select the follicle here and follicle shape. Rest pose, where are we? Point lock at both ends, just at the base of the curve. And now it falls away onto the floor. Now we would need to either put a colliding plane in. So if you wanted to use your own floor plane, you can just do this. And then we would need what we want, N-cloth, create passive collider. And let's see. There you go, and that falls on the floor like so. Now we do need something with some thickness on it. So we can't just have this. I mean, that's, you know, it's just a curve. But we could just extrude some geometry along this curve. So let's do that. Let's start with a NURBS, or circle should do it. And let's scale this bad boy up a bit so I can actually see what I'm dealing with. And let's get this thing till it's about the thickness of this. Now this is not magically going to do everything for you. So we might need to do some tweaks afterwards. I'm just going to grab this and this, hit Ctrl+1 to isolate them. Select this guy, lock him to curves, and lock him to the curve. There we go. So I'm going to kind of see where is this curve going. So it might be a little bit twisted this way, but again, something we can always change later on. Ctrl+1 to bring everything back. Get this about the size you need it. So about the size of this hole should do. And then we're going to select the NURBS circle and the output curve under here. Okay, so then it's just a case of surfaces extrude. And where are we? I'm sure I am just blind. I am indeed just blind. Now ours is a little off the original target, but if we simply rotate here our circle a little bit, we should be able to get those back into line with each other. So I'm actually rotating the curve, not the circle. And there you go. Okay, so let's drop it. And we have what looks like a bit of cable running along the floor. Now, obviously, there's much more to this than just what we've done here. But if that's all you ever learn in Maya Dynamics, you know, that's not a bad start. That's a very easy way to take your ArcViz shots and run a little bit of cable on them in a sort of manner that's consistent with, you know, naturally falling cable. Okay, now there are hundreds of options with this. This is just the very tip of the iceberg, which, as I say, I will be covering a bit later on. Now, we can duplicate this object, and now because we don't need it anymore, I'm going to delete the history on it. Edit, delete by type history. Sorry, because we don't need any of this. So all of this can go. I'll leave my plane in there, I think, and gone. Did I delete the... Yeah, I did, because of course I did. So let's see, it's this one I wanted to keep, wasn't it? Okay, now I have this NURBS surface, which we've dealt with before, so I'm going to convert it to a polygon. So modify and convert NURBS to polygons. Now I'm probably just going to use control points. I'm going to tessellate. I am going to delete the history on it. And I'm going to get rid of this surface. Now I should have something that nicely easily smooths, and also I can come in here, start grabbing some of the verts and simply moving them around where I need them to be. So I might get this a bit straighter and then shove it in here. I am still on snap to curves. Okay, so you can, you know, thicken that up a little bit maybe so it fits more exactly. You can grab any bits you don't like, use the soft selection tool, come in, maybe change them about a little bit. But that's a really quick way to drop some cable on the floor. Now, it's also worth noting at this point that if we'd had objects in the way, we could have also set those as enclosed passive colliders, and the cable would have draped over those as well. So this gives you a very flexible method. Maybe you're doing a scene with a Betty floor, you've got some shoes in the way, and the cable's draped over the top. So it's not just for dropping cable on the floor. As I said, there's a whole rabbit hole to be going down here, which we will be doing later. But for now, that's all I have, so I will see you in the next part. Thank you for watching. Welcome back. So I'm in a file here that I've imported all the bits and bobs we've been working on, kind of creating a reusable component library for sets. So I want to talk about this coving first off and why we left it hollow when we modeled it. Now, it's because I can do this with it, which is run one contiguous object around an entire room regardless of room shape. And then when we meet at either end will be one continuous solid piece of geometry. Now I'm going to show you how to do this. I'm also going to show you how to close this off with the correct topology should you need to. So I'm going to isolate this guy in the viewport first. I'm going to create a duplicate of him, just so I have one saved in case it all goes wrong, which I'm sure it's not going to, but you never know your luck. And then I'm going to scale this down until it's one grid unit wide. Now, you don't have to be terribly accurate with this. Close enough is fine, especially for this demonstration. So about one grid unit wide. Now, we'll be scaling it up, of course, at the end. But for right now, this is absolutely fine. Now, in order for this to work, I'm going to put some temporary faces on this guy. So I don't need to worry myself too much about the topology or if they're n-gons or any of that business, because they're only going to be temporary. So I'm going to bridge across here, come out to the other side, and bridge across here. Now I need to flip this face, or you could select these vertex around here, it doesn't matter, but I need to flip this face 45 degrees. So I'm going to hold J and go 1, 2, 3, and that will be 45 degrees because by default we are locked in 15-degree increments. I'm then going to scale the face in both X and Z at the same time, X and Z at the same time by hitting Control and scaling Y. Now I'm going to scale that up until it's one grid unit. So it makes the grid here very easy, very handy for us, and we are done. Now, if I want to run this out, I'm going to hit Control E, and I'm going to come this way. If I wanted to bend round, say, a complex corner, now normally I would do this in situ in the room, but if I want to bend around a complex corner, I hit Control E again, and I can go this way. So I can create very complicated coving profiles, skirting board profiles, that sort of thing, with the barest minimum of fuss. So let's come in and create a square. And as I mentioned, I think one of the reasons I like to create a square is because a lot of rooms are just square. So if you've got a square in your reusable component library, it makes it a doddle to bring it out. Now, if I check my view here, you can see that's the same width as this. In fact, let's do an extrusion. And you'll see they're all one grid unit. Now, I've missed the grid a bit. It doesn't matter, but I think you can just eyeball the fact that this and this are the same. So now I need to come in and I need to start coming this way. So again, this is not difficult. We're just going to flip the faces again, as we did. So 1, 2, 3, 4, 5, 6. That was 7. Control E to extrude it, and let's come out a little bit this way. Now both of these guys have to meet in the middle, so I am going to not extrude that, sorry. I am going to rotate it, of course. 3, and again I'll have to centrally scale it on X and Y. X and Z, sorry. So around here, now you could take some time making that exact, but I don't think I really need to for the purpose of this demonstration. I'm then just going to move it until it lines up nicely with this edge here. So somewhere around there. Now you could take, again, as I said, more time there, but I'm just demonstrating this technique. Now, we need to remove both of these faces. So let's go and remove this face and remove this face. Then I'm going to select this edge and convert the selection to vertex. And then I am just going to scale them all together. I'm going to do the same with this guy. And scale them all together. And now I can simply select the edges and bridge across. When I've done that, I can remove these bridging edges that I no longer need. And there we go. There we have it. We've got a square. You can then come in, if your room happens to be square, and size it for whatever room size that you need, very quickly and very easily without having a bunch of extraneous objects in your scene. And there you go. Now you can bevel these edges if you wanted to. You could smooth this if you're using smooth geometry, and you're done. And you can also bend it round extremely complicated profiles, room profiles and whatnot. So that's one reason that I leave this thing hollow. Now, let's say that you needed this thing, for whatever reason, filled in properly. Well, with a object like this that's been created from a profile, let me just duplicate it. So we're working on the duplicate object, and I'm just going to isolate this. With an object like this that's been created from a profile, this is actually really, really simple. All you need to do is cut some faces. So let's cut the top face and the bottom face and cut. Just delete those, and we're left with just the front. Now I'm going to double click this and I'm going to go to edit mesh. Let's see, duplicate faces. Now you don't want to pull this, it'll start extruding them all over the place. You want to go down to outliner and just select it here. Now I'm going to push this back to approximately where the back of this thing was. I'm going to select all the vertex on it, like so, and then I'm simply going to bridge all these edges with all these edges. Okay, so I'm going to go into edge mode selection. I'm going to select up here and I'm going to start selecting all the edges down the side of this thing. Now, worth noting that before I actually start this, in order to bridge this one with this one, they need to be one object. So let's click this one, and hit Mesh Combine, which we've got up here on our shelf. And now we can select the edges. Now, again, though, when this is bridged, this will be the inside of the model, and currently it's not. So this should be the side of the model, the outside of the model. We've got it the wrong way around. So just select all the faces and get a mesh display reverse, and that will now be the inside. It's black, and that will be the outside. Okay, if you did your bridging operation with it the other way around, it would come in hideously tangled. So if you get a hideously tangled bridge operation, it's often reversed faces somewhere in the equation. So let's select these edges again, faces, edges, and all the way down at the bottom one, remembering to get the one right at the very bottom there. Then I can come up here, select this one, and now I've got both edges selected. I simply need to bridge across, and I would need to, of course, bridge across the top as well. But that should be as simple as selecting this guy, and if I can get a good view on it, this guy, and bridge, and we're done. Now I would just mirror this. We've got the bottom hole here to fill in, ginormous gap that I seem to have missed. And bridge. There we go. So that's a filled in object. Now, of course, you would need to then mirror this across, like so. And you've got your filled in correctly, well, with the correct topology. We can check it if you'd like. I'm going to go into face mode to just do a check. N-sided, we have none. Let's see. Quads, n-sided, none. Triangles, none. So that's two things you can do with sort of these coving skirting board profiles and whatnot. You can either fill them in, like so, if you just need one straight piece, or you can actually bend and twist them into complex shapes. Okay, now I'm not going to demonstrate the same thing with the skirting board because it's a much simpler object, and I think that you get the point. Now, one other thing I wanted to go across was these doors. So this is the single door and this is the double door. Now let's check out the differences. The single door has a lip down this side, the double door does not. So that's relatively simple. Just cut those faces off and then bridge across the remaining geometry. So I'm not going to go through that. What I am going to quickly go through is how we get this door over here with all the door furniture in the correct position. Now, by the way, this going down the door here is just quite simply a door block. It's what, after looking this up, double doors have on them. So I'm going to take my double door, I'm going to take the whole door here, and I'm going to combine it into a single object. Like so. Oh, I must have had some hidden geometry in the group. It's a spare strike plate. Doesn't matter for this demonstration. Now I need to get this door over here, but I need it mirrored. So we can, in fact, just use mirror for this. So we'll come in and hit the mirror. And we'll want this on, say, bounded box on a -x, and I don't want the border to merge, so don't merge the border at all, and then I'm going to use the offset to move it over here a bit. And you'll notice now that my handles are reversed, my door furniture is on the right side. I can now come in and separate these guys, which I also have up here. Now this door jamb on the back door is actually, let me center the pivot for that, is actually on the back of the door, not on the front of the door. So we need to do this, like so. So that has its lip there, and of course one side wouldn't have the lock or this, it would just have the strike plate, whereas the other side certainly would have those. Okay, I'm going to turn wireframe unshaded on because it's a little easier to see. So the other side has that, this side has this. Now it's just a case of moving your doors together, of course, and arranging them into a group. So I want to do the same thing with this handle, just as another demonstration. So I'm going to get everything that makes up the handle here. And obviously the handle designed to be smooth, but it doesn't matter for right now. And then I'm going to mirror that lot onto the back of the door. So let's combine that. Combine, and I'm going to center its pivot, and then I am going to mirror it over to the back of the door. So I'm going to mirror that. I'm just going to put it on bounded box for now, and that should be in Z, like so, and then I can just use the offset to bring it where I need it. Now it doesn't really matter. I'm going to take the merge border off. Do not merge the borders. And there we go. That's in approximately the right place. We'll be able to move this around later on. It will be one contiguous object anyway. Done. Okay, now I'm going to separate this. So separate. And there we go. I could smooth it again if I wanted to, obviously. And now I have a handle on the front and the back of the door. And I have my two doors. I also went ahead and modeled a slightly different door frame here, just so you'd have one in your library. It's basically exactly the same as this one. It just has a slightly different profile to it. Now, let's have a look at some organization. So I'm going to delete all of the history on this entire scene. I don't want any of it. So edit, delete all by type history, and that cleans my outliner up a bit. And now we should really start cleaning our outliner up. So you're going to want to select sort of all the components that make up one door here. Now I'm not going to run through this too much because it makes no difference to the modeling. It's more a question of your organization and moving things around and whatnot. So once I've got everything, I left the door furniture behind. I'm just going to group it, and then I would name that group. Now, I'm not going to get too organized right now because I'm going to have to recombine some of these in a moment, but let's get everything that makes up one door just as an example. And did I get haven't got a handle on the back yet, so that's okay. And Control G, and you will see in here has been created group 1. I can then go in and call this door left or whatever I need to. I can start then splitting it down into its component parts, so subgrouping the handle and whatnot. Control G, and deciding what goes with what, but for right now this is fine. So I'm going to center the pivot on that group and whack it onto the door frame. Now one more thing that I want to go across is I don't need either of these. Flapping about in the breeze. One more thing is just, you'll notice that this door's taller. This is the height of a standard door. This would be the height of something you'd see in like a very swanky house or a swanky hotel room, which is part of the scene that we're actually doing. So I am going to come along and just show you how to quickly resize this door. Now in this case, this one will be quite simple. I'm going to get the frame as well. So really simple. Design these components to be sort of reusable, resizable without much of a problem. Now I want to get all of the strike plate in for the next one, so I need to be moving all of this, and I'm going to shove this up, making sure I've got all the edges I need. I'm going to shove this up. Now if we moved it into the reference that we first built, then of course we could get this exactly sized. That's the reason we built the original room reference in the first place. But I'm going to leave that as an exercise to you because it's simple enough. That's one of the reasons why we built it that way. Okay, I'm just showing you here quickly how you can go about resizing this kind of stuff. And you can now move the handle and the door furniture up into the correct position too. So making sure you're on object mode and that you've got everything. Now I actually measured this door handle. If we move it up here, it's going to be about 120 centimeters off the floor, which according to an American woodworking magazine that I read, was absolutely fine. That's sort of the high height for a door handle. Okay, now obviously resize things like this bar here and down there. It's fine, of course. Okay, so I am going to make sure that I have all this. What is this piece here? What is that? Is that part of a... Where are my hinges? Ah, those are my hinges. Okay, so I need to get my hinges back out, and a few other little odds and bits and bobs that have been left over for some reason. But again, I think you get the point here. Now, right at the end of this tutorial, I will show you the scene that we built at the beginning of it, the room we built at the beginning of it, with all our things imported into it, just so you can see. And again, when we import them in there, they might need to be slightly resized. But we've built everything in such a way that it's genuinely quite easy to resize it. This is supposed to be, you know, a library for us, so when we're doing an interior or a set, we can come in, grab a door handle, grab a whole door and door frame, grab some skirting board, grab some plug sockets, some cables, some plugs, etc., just to make the whole process a bit less tedious every time. Okay, so I'm going to come back in the next part where I will show you how to UV some of this stuff. Thank you for watching. See you in the next part.